Good morning, everybody. Today we're here to have the Streamlining Launch and Reentry Requirements Final Rule Part 450 workshop. This morning I'd like to introduce, to kick off the workshop, Mr. Wayne Monteith.
Hey, thanks, Michelle. Hey, good morning, everyone, and thanks for attending our workshop. And I hope you get as much out of the next 3 days as I know we will. For AST, this is an unprecedented rulemaking effort in scope, and quite frankly, historic in terms of schedule. This was also an incredible team effort, not only from our interagency and industry colleagues, but also from the FAA, the Department of Transportation, OMB, the National Space Council, and OIRA. But now that the hard work is complete, the real hard work begins, and that's implementation and advisory circulars. So, previewing the next few days, we have a very, very busy agenda and we'll cover a lot of ground. But this will not be our last workshop, as we are already looking to do this again in the next quarter, after you've had a little more time to review the new rule. A few additional thoughts. This is about the rule as written and helping you understand what is actually in the rule. Unfortunately, this is not about rewriting 450 already, is that ship has quite frankly sailed. So these sessions will be of greatest value if you are engaging with our team through both the Q&A opportunities and the individual company sessions that will be available. Finally, we are also previewing to you draft, and I'll foot stomp draft, work products like checklists that we plan to make available after a government review process should you want to use them. They are not mandatory and they are not regulatory in nature, but they do respond to your request for AST to provide additional clarity to navigate the licensing process. So your inputs are very, very important. And one last item. I did sign the ground safety policy yesterday to bring our legacy regulations in line with 450 in an effort to reduce duplicative requirements at Vandenberg, Cape Canaveral, Kennedy Space Center, and Wallops. Thanks again for attending, and I very, very much look forward to your feedback. Now, back over to you, Randy, to kick off this workshop. Thanks again, everyone.
All right, thank you, Wayne. Can we go to the next slide, please? The next slide. Okay, first I want to welcome everybody to this workshop. It's 3 full days, and we realize it's a lot of time to commit to this, so we really very much hope it's beneficial for everybody. So just to say a few notes, as most of you know, that the Streamlined Launch and Reentry Licensing Requirements rulemaking was posted on the FAA website on October 15th, 2020. And the rule will be effective 90 days after publication in the Federal Register. Now, has not been published yet in the Federal Register, and I don't have a date for you of when that's going to be, but it shouldn't be too much longer. We don't control that, but it should be certainly weeks, not months. So as Wayne mentioned, the purpose of this workshop is to assist industry in understanding the requirements in the new Part 14 CFR Part 450. And like he mentioned, we don't want to re-adjudicate why we did something, but we do want you to understand what's there as best we can. So because this is a virtual session and there's a lot of people involved, we really can't have a lot of give and take with the industry partners. And so we are planning on holding individual sessions with licensees and applicants after the workshop to address questions pertaining to their unique programs. And we're very much looking forward to that. As most of you know, throughout this rulemaking process, we haven't had the opportunity to have a lot of give and take. Probably since the ARC back in 2018, there hasn't been a lot of give and take. And so we'll do some of that here in this workshop, but certainly with our individual sessions, we very much look forward to talking to individual companies and really seeing how 450 can work for them. And also, as Wayne mentioned, probably once a quarter for the next year or so, we'll probably have a one day or a morning workshop to cover new items that have come up since then. Next slide. So here's an overview of the agenda, and this is just kind of a top level. So it's 3 days. So today we're going to try to get through a Part 450 overview, and that's like an executive summary of the rule. And Michelle Murray will do that. And then Ken Wong is going to talk about some tools, some helpful aids we've put together for pre-application consultation. And so he'll go through a number of those. And then we'll jump into the rule with Subpart A and B. And then we'll start with Subpart C, trying to get to the safety criteria, the system safety program, and the hazard control strategies. And then tomorrow is all about Subpart C, continue with hazard control strategies, and then we'll go into flight safety analysis and computing systems. And then Friday also we'll continue with Subpart C to go through safety critical systems, flight safety systems, and then other prescribed hazard controls. And then we'll get through ground safety and Subpart D. And at the very end, we have another aid we've put together that's a crosswalk that tries to crosswalk the Part 450 requirements with Part 417, 415, and 431 to try to show how the requirements in 450 relate to some of the requirements in those other rules. And so also, it's a pretty packed agenda. What we're going to try to do is stay on schedule as best we can. We definitely want to keep the items we plan on doing during a given day on that day. So if for some reason we get done early today, we're not going to do Thursday morning's item today. We want to be able to make sure that people can plan to have their experts review the sections they want to see. And so we'll try to keep on schedule, but definitely in a given day, we'll only do that day's agenda. Okay, next slide, please. Okay, questions and answers. So because of this environment we're in, we're going to try to answer as many questions as we can. So after each section or a set of sections, there'll be parts of the agenda that will be set aside for questions and answers. And so what we want you to do during the briefings is, if you have a question, there's a Q&A function on Zoom here. Use that to type in your question. And what we're going to do as we get these questions, we have a team that's going to try to put all these questions together. And then when it comes down to the Q&A session, we'll queue those up and try to answer as many questions as we can. We don't think we can get through all the questions. And so what we are going to do after the workshop, we will publish a written Q&A document with all the questions and written answers for every single one. So if we don't get to your question in this workshop, don't worry, we will have it written down in a document later. And we very much look forward to the individual sessions, like I mentioned, to really have a much more a better give and take. But we'll do the best we can with questions and answers in the format we have. All right, thank you very much. And over to Michelle Murray.
Okay, good morning, everybody. So Randy pretty much covered the agenda for the first 3 days. Today, we're going to go a little bit more in depth on an overview, as he mentioned, for the first hour. And then we're going to go over some pre-application consultation templates and guidance. We'll have a Q&A at that point in time and a lunch break, and then we'll go into Subpart A. Next slide. And Subpart B. Then we'll have another Q&A session and break, and we'll start into Subpart C with our safety criteria, system safety program, and hazard control strategies. One other note I'd like to say with regard to the questions and answers is that, as Randy mentioned, we're going to be following up with written answers, but also please consider all of our verbal responses preliminary. We're thinking on our feet, and we haven't done full consultation with our entire team. So please consider any answers given in this workshop verbally as preliminary. Another note before we go ahead and get started is that our website, our Part 450 website, has just been updated. And you can access that by going to faa.gov/space and clicking on the little blue box that says Streamlining the Regulations for Launch and Reentry Activities. And you'll find the charts for today, an updated agenda. And then if you scroll down a little bit under the licensing process, you'll see the pre-application consultation templates and guidance. Those are also on the website for you. So I'm first going to spend a little bit of time up front to give you an overview of the entire rule so that you have a top-level understanding of it before we go and do deep dives into each section. Let's go ahead and get started. Next chart. So the streamlining launch and reentry licensing rule, known as SLR2, was the result of a lot of work on the part of industry and government. The FAA's team of engineers, attorneys, economists, and rulemaking staff, and the very significant input from industry through the ARC and the public comment period, as well as our government partners with DoD, NASA, DOT, and OMB. What would normally take 5 to 7 years, we completed in 2.5. This rule consolidates the rules for expendable launch vehicles, reusable launch vehicles, and reentry vehicles into one performance-based rule for all vehicles. SLR2 is a performance-based rule that utilizes a flexible means of compliance, and that means it can grow as the industry grows and innovates. SLR2 allows a single license to authorize multiple sites, and the rule was a product of extensive coordination with our government partners, which results in minimum duplication requirements for operators. Next chart. So the way that the rule is divided up, it's in subparts A through D, where subpart A are the general requirements, and subpart B are requirements to obtain the license, and subpart C is your safety requirements, and subpart D is terms and conditions for the vehicle operator license, and that's typically after the license has been issued. Going a little bit further into subpart B, Bravo, the application requirements are separated from safety requirements to facilitate compliance planning, and that's in subparts B and C, to allow a more efficient licensing process so that an applicant knows exactly what is required by looking at the application requirements. The safety requirements are what an operator must do to be safe, and then the application requirements detail what must be submitted in an application. For example, on the right-hand side, you'll see 450, 155 for readiness, and there are the general safety requirements, and then in B, there are the application requirements. And this is the way the whole rule is organized. Next chart. So going into a little bit about the vehicle licensing process, it begins with pre-application consultation, as it always has, which sets the stage for an applicant to submit a license application. The application evaluation consists of 5 major components: a safety review, policy review, payload review, a financial responsibility determination or maximum probable loss, and an environmental review. The license specifies the range of activities that the licensee may undertake, along with any limitations. Requirements after a license is issued encompass the licensee's responsibility for public safety and compliance with its license, representations in the application, and FAA regulations. An important component of this compliance is the FAA's authority to perform safety inspections. Next chart. So this chart is a little bit new from what folks have seen in the past, and this really embodies what Part 450 is all about, and that is having one operator's license that will last the entire life cycle of a program. The graphic depicts the licensing process starting with pre-application consultation at the top, and then it moves over to the right with an applicant coming to us and proposing unique means of compliance or accepted means of compliance, any equivalent levels of safety or waivers, and then the application would be accepted, and then the FAA evaluates, and then there's the 5 reviews that take place. When the FAA makes a determination, it's compiling the license and license orders and what we're calling a compliance document set, and then it issues the license. And this process will repeat and that's where we have the life cycle management. Once a license has been issued, you would continue to maintain that life cycle through modifications. On the far right side, you'll see some of our pre-application consultation planning templates and guidance, and those are now on our website, and they are draft. So we welcome your feedback on those. And on the left side, you'll see our license and license orders and referencing that entire compliance document set. Next chart. So pre-application consultation is designed to increase the efficiency of the licensing process now so that it's focusing on compliance planning. The length of pre-application consultation will vary based on the proposed operation. It would be longer for brand new vehicles that are under development and shorter for previously licensed vehicles or operators who are experienced in using the FAA's regulations. During pre-application consultation, the FAA expects to discuss the following topics with an applicant. And that is primarily the intended means of compliance to meet Part 450 requirements, a discussion on the scope of license, the use of any safety element approvals, whether or not the operator is interested in an incremental review, the review period for the license evaluation, compliance expectations, and timeframes. Next chart. So to dive into each of these items a little bit closer, pre-application consultation in the discussion about the scope of license, it does include the beginning and end of the licensed activity, whether it be beginning of launch or beginning of reentry, and then end of launch and end of reentry. But the area that we find most discussion will be had is most likely on the beginning of launch. The applicant will describe its launch site and intended concept of operation leading up to the launch, including any hazardous pre-flight operations. The FAA will identify the beginning and end of launch on a case-by-case basis in consultation with the applicant. Launch will begin with hazardous pre-flight operations, and some of those can include, but are not limited to, pressurizing or loading of propellants into a vehicle or launch system, operations involving a fueled launch vehicle, the transfer of energy necessary to initiate flight, or any hazardous activity preparing the vehicle for flight. Hazardous pre-flight operations do not include the period between the end of the previous launch and launch vehicle reuse when the vehicle is in a safe and dormant state. And that's to accommodate a lot of the reusable vehicles. Additionally, to accommodate reusable vehicles, the end of launch now uses terminology impact or landing to determine when the end of launch or reentry occurs. Next chart. Another area for pre-application consultation is the incremental review of a modular application. This is completely optional. You always have the option to submit your entire application at one time, but we've always previously allowed independent reviews of payload review, policy review, MPL, and environmental review. Part 450 now allows an incremental approval of parts of the safety review. So now the entire application is open to this incremental type of review or independent reviews. And the thing that's nice about this is that it then gives you some regulatory certainty that things have been approved in advance. An applicant must have its incremental review approach approved during pre-application consultation. So you can't just submit one piece and have it approved. We need to have a plan so that we know that the modules are going to be coming in, that they can be reviewed independently, and that they're going to be submitted in a workable order, because there's many interdependencies of different modules within the safety review. So I mentioned the benefit of the incremental review is to have some of that regulatory uncertainty with the early approvals. It also allows for, if you have modules that have been approved in advance, that the FAA can negotiate with the operator to approve a review period, an FAA review period, that can be less than 180 days. Next chart. Another efficiency improvement with pre-application consultation in Part 450 is safety element approvals. Part 450 now makes it easier to seek a safety element approval in conjunction with a license application. So it doesn't have to be a separate application. And this, we think, will increase the efficiency of the licensing process, because the applicant can then leverage any existing safety element approvals in this license application that they're doing it concurrently with, or in any future applications where there's modules that would be the same. A safety element approval is a determination that a safety element, when used or employed within a defined envelope, parameter, or situation will not jeopardize public health and safety or the safety of property. A safety element is one of the following items: a launch vehicle, reentry vehicle, safety system, process, or service, qualified or trained personnel performing a process or function related to the licensing activities or vehicles. One thing you might note is there's a lot of changes in Part 414 that is merely just the change of the term safety approval to safety element approval. And we did that because we wanted to delineate between the safety approvals given during the licensing process versus a Part 414 safety element approval. Previous to this rulemaking, they used the same term. Next chart. Part 450 features flexible timeframes, which is another topic that will be discussed in pre-application consultation. Part 404 Appendix A lists the timeframes that an applicant may request a change to the default timeframe required by the regulation. The FAA will conduct its review on a case-by-case basis, taking into account the complexity of the request, the timeliness of their request, meaning how far in advance do you give it to us, and whether or not the requested alternative timeframe allows sufficient time for the FAA to conduct its review and make its findings. The FAA expects alternative timeframes to be proposed and accepted either during pre-application consultation, during the application process, or after a license is issued through the license modification process. Flexible timeframes may be negotiated for all launches or reentries under a license, so you don't have to renegotiate that for every launch. The table on the right is a copy of the Appendix A to Part 404 listing the various timeframes that are eligible to be flexible. Next chart. The primary focus area of pre-application consultation is compliance planning. So the means of compliance is a big part of the pre-application consultation discussion. An applicant may demonstrate compliance with Part 450 requirements using accepted means of compliance. Means of compliance can be a government standard, an industry consensus standard, or unique means of compliance developed by an individual. If an operator takes an accepted means of compliance and tailors it, they would then submit that to the FAA as a unique means of compliance. There are also 5 sections where a means of compliance must be accepted by the FAA prior to the FAA accepting an application. Those 5 are listed here, and they are the methodologies for flight safety analysis, toxic hazards for flight, highly reliable flight safety systems, lightning hazard mitigation, and toxic hazard mitigation for ground operations. For all other requirements in Part 450, an applicant can submit the means of compliance as part of its application for the FAA to review during the application evaluation. One other note that's really important is a means of compliance can be submitted to the FAA outside of the licensing process by anyone. So those standards organizations or industry consensus standards, those can be submitted to the FAA to be included as accepted means of compliance. Next chart. So now I'm going to talk a little bit more. I'm going to shift gear. Those were the key areas of pre-application consultation. I'm now going to talk about the safety framework of Part 450. Part 450's safety framework provides the flexibility needed to accommodate current and future launch and reentry operations. It starts with a system safety program, which establishes system safety management principles for both ground and flight safety throughout the operational life cycle of the launch or reentry system. Ground safety is achieved primarily through a process-based hazard analysis used to derived hazard controls and also prescribed hazard controls. Flight safety is achieved through a combination of prescribed hazard controls and hazard controls derived from the flight safety analysis and the hazard control strategy determination and implementation. The safety criteria are kind of our core requirements, our core standards in 450-101 that must be met before a launch or reentry can take place. The safety criteria include collective risk, individual risk, aircraft risk, risk to critical assets, protection against high consequence events, disposal of orbiting stages, risks to people and property on orbit, and notification of planned impacts. Next chart. So going through some of these a little bit more in depth, the system safety program requires that all operators have a system safety program. It should establish system safety management principles for both ground safety and flight safety throughout the operational life cycle of the vehicle. And the system safety program includes your safety organization, hazard management, configuration management and control, and post-flight data reviews. Next chart. The 4 hazard control strategies in Part 450 accommodate the wide variety of commercial launch and reentry vehicle systems and operational concepts. They are physical containment, wind weighting, flight abort, and flight hazard analysis. An operator determines the appropriate hazard control strategy by conducting a functional hazard analysis. An operator may use multiple hazard control strategies during flight because different strategies may be appropriate at different phases of flight. Different hazard control strategies may also be appropriate during any one phase of flight in order to protect different sets of people or different sets of property. An operator is required to use flight hazard analysis if the other hazard control strategies cannot adequately mitigate the public safety hazards in order to meet the risk criteria in 450-101A, B, and C. Next chart. In this rule, we've been speaking to prescribed and derived hazard controls. Just very quickly, derived hazard controls are not specified in Part 450 because derived hazard controls are derived from the process when you're demonstrating compliance with the safety criteria in 101, and also through the output of the various safety analyses, such as flight safety analysis, hazard control strategies, and system safety. Examples of derived hazard controls include flight commit criteria, flight hazard analysis, flight abort rules, and some of the other mitigation measures. Next chart. Prescribed hazard controls. So in addition to the derived hazard controls, Part 450 features some prescribed hazard controls. We have them in 2 sections, one for computing systems and safety critical hardware, and then the other is with other prescribed hazard controls. Regardless of the hazard controls that were derived from the flight hazard analysis, flight safety analysis, and the FAA requires other hazard controls, and these are your prescribed hazard controls. The first set for those computing systems and safety critical hardware are for, obviously, your computing systems, but also all of your safety critical systems, including highly reliable flight safety systems. The next set under other prescribed hazard controls are ones that have historically been necessary to achieve acceptable flight safety. And these include things like written agreements, safety critical personnel qualifications, crew rest, radio frequency management, readiness, communications, pre-flight procedures, control of hazard areas, lightning mitigation, flight commit criteria, tracking, collision avoidance, safety at the end of launch, and mishap plans. Next chart. So to summarize what we've covered so far, this diagram gives a graphical depiction of the safety framework. At the top, you'll see how the system safety program is for all vehicle operators. The next level down shows the ground and flight safety. And on the flight safety side, you have both the flight safety analysis and hazard control strategies. I'll go into those next, but you can see that there are 4 hazard control strategies that can be used alone or in combination by phase of flight. You'll also note that under flight safety analysis, there's a high consequence event protection that feeds into the hazard control strategies where the high consequence event protection might require the use of flight abort as a hazard control strategy. You can also see how all of these analyses result in derived hazard controls, which when combined with the prescribed hazard controls results in acceptable ground and flight safety. And I'll go into some of these other elements on the next charts. Next chart. So now that you have the framework, I'll take a minute and give that brief description of the 4 hazard control strategies. The first 2 are the most simple, physical containment and wind weighting. Physical containment hazard control strategy is designed to be a simple method for protecting the public by launching in an area that's clear of the public and critical assets, and within an area that contains the hazards based on the energy of the vehicle. Physical containment is most likely used for low energy test flights when the vehicle does not have enough energy to reach the public or critical assets. Wind weighting is traditionally used for unguided suborbital rockets or sounding rockets, where the operator adjusts launch azimuth and elevation and to correct for wind conditions at the time of flight to provide a safe impact location for the vehicle and its components. Next chart. The next hazard control strategy is flight abort. Flight abort is a traditional safety approach for ELVs or expendable launch vehicles and is a process to limit or restrict the hazards to the public and property by initiating and accomplishing a controlled ending to vehicle flight. And you'll note that our definition, controlled ending to vehicle flight, is very accommodating for both RLVs and ELVs in this case. With the exception of the phases of flight with demonstrated reliability, flight abort is mandated as a hazard control strategy if the potential for a high consequent event is above a certain threshold. The flight abort requirements are in 450-108, and they include flight safety system requirements, flight safety limit objectives, flight safety limit constraints, end of flight abort, and then flight abort rules. Next chart. So the 3 main questions on flight abort are, is an FSS required, a flight safety system required? What FSS reliability is required? And when is the FSS activation required? It's a pretty complex concept, so we've graphically laid it out. If your CEC is less than 10 to the minus 3, then you do not need an FSS. Also, if you have demonstrated reliability, you would not need an FSS. There's also, if your CEC is between 10 to the minus 3 and 10 to the minus 2, then you need an FSS in accordance with 450-108B2, and its requirements are set forth in 450, its reliability requirements are set forth in 450.143, the safety critical systems requirements. If your CEC is greater than 10 to the minus 2, then you need an FSS in accordance with 450-108B1, and the reliability requirements are 3 nines and 95% confidence, and it's laid out in 450-145. Both, if you need a flight safety system for the 108B1 or B2, you would still be using for when to activate the flight safety system. All those rules are in 450-108. One important note also is that on the side where you don't need an FSS, in accordance with 450-37, which is the equivalent level of safety, an applicant may demonstrate an equivalent level of safety to 450-101C2, which is that other note in that first column under not requiring an FSS. Next chart. The last hazard control strategy is flight hazard analysis. Flight hazard analysis is the traditional safety approach used by reentry vehicles and reusable launch vehicles, and it is the most flexible hazard control strategy because an operator derives its specific hazard controls unique to its system and operations. Flight hazard analysis is mandated as a hazard control if the other 3 hazard controls cannot mitigate the safety hazards sufficiently to meet the safety criteria in 450-101. A flight hazard analysis must identify and describe and analyze all reasonably foreseeable hazards to public safety resulting from the flight of a launch vehicle, mitigate the hazards, and then verify and validate the hazard mitigations. An operator using flight hazard analysis must identify new hazards throughout the life cycle of the launch or reentry system, ensure that the flight hazard analysis is complete and that all hazards are mitigated prior to flight, and continually update the flight hazard analysis throughout the life cycle of the launch or reentry system. One note also is that hazards associated with the computing systems and computing systems are further addressed in 450-141. Next chart. So moving over in the other branch on that safety framework under flight safety analysis, Part 450 contains performance-based requirements for flight safety analysis component analyses in the order that they're typically performed. All operators are generally required to conduct a flight safety analysis, regardless of which hazard control strategy they've either chosen or has been mandated. An operator is not required to perform or document a flight safety analysis for a phase of flight if agreed to by the administrator based on demonstrated reliability. An operator demonstrates reliability using operational and flight history to show compliance with the risk criteria in 450-101A and B. A flight safety analysis includes trajectory analysis for normal and malfunction flight, a debris analysis, population exposure analysis, and probability of failure analysis. These analyses provide input to debris risk analyses, DFO or far field overpressure blast effects analysis, and toxic analyses that together demonstrate compliance with the safety criteria of 450-101 and provide input to the flight hazard area analysis. Next chart. On the far left side of the framework is ground safety. With respect to the safety of ground operations, the safety framework includes coordination with the site operator, explosive siting, ground hazard analysis, toxic hazard mitigations, and some of those prescribed hazard controls, such as addressing visitors, countdown aborts, fire suppression, and emergency procedures. Together, they provide an acceptable set of public safety considerations for ground operations. Operators are not required to perform a toxic hazard analysis for kerosene-based fuels unless directed by the FAA. Next chart. So with regard to the safety criteria and neighboring operations personnel, neighboring operations personnel means that those members of the public located within the launch or reentry site or an adjacent site who are not associated with the hazardous licensed activity currently being conducted, but are required to be there to perform safety, security, or critical tasks at the site and are notified of the operation. Separate NOPS risk acceptability criteria reduce the need to evacuate the neighboring launch operators' personnel during a commercial launch or reentry operation. Part 450 allows NOPS or neighboring operations personnel to be protected as members of the public, but to a less stringent risk threshold. So for collective risk to the public, it's 1 × 10⁻⁴, but NOPS are 2 × 10⁻⁴. And for individual risk, the public is 10⁻⁶, and NOPS is 10⁻⁵. Maximum probable loss for NOPS is 1 in 100,000, which is the same as government property. And you can compare that to third party, which is 1 in 10 million. The federal or licensed site operator is the one who determines who are going to be designated as NOPS in coordination with the operators at the site and in accordance with the definition of NOPS. And it's important to note that NOPS is optional at non-federal sites. Next chart. Critical assets and critical payloads. Critical assets include property, facilities, or infrastructure necessary to maintain national defense or assured access to space for national priority missions. Critical assets that are part of the immediate launch or reentry complex used by an operator are exempt from the critical asset protection requirements. Critical payloads include a payload and essential infrastructure directly supporting such a payload that is a critical asset. A critical asset is so costly or unique that it cannot be easily replaced, or for which the time frame for its replacement would adversely affect national interests of the United States. The FAA will consult with its interagency partners regarding critical assets, and the US government will assess the impacts to critical assets in flight hazard, ground hazard, and debris or debris risk analyses. So in summary on that is the FAA or the government will conduct the critical asset analysis. Next chart. High consequence event protection. An operator must protect against a high probability, an operator must protect against a high consequence, low probability event. Part 450 allows an operator to use a method other than flight abort in certain situations where an operator can show sufficient protection against high consequence events. Demonstrated reliability as approved by the administrator, or demonstration that CEC is no more than 10 to the minus 3. The FAA retains the CEC requirement as quantitative criterion that an applicant must use to measure high consequence event, but it allows for an equivalent level of safety for the CEC requirement, and the AC on high consequence event protection describes an alternative means of compliance. Part 450 also allows options on how an applicant may protect against a low likelihood high consequence event in an uncontrolled area for each phase of flight by using 3 ways: using a flight abort in accordance with 450-108, demonstrating that CEC is below a certain threshold without the use of an FSS, or demonstrating sufficient vehicle reliability based on CEC, which again is discussed in the AC. Next chart. So taking a quick look at this reg, 450-101C has 3 parts to it. The first is, as we just discussed, where an operator may protect against high consequence events by choosing to use flight abort in accordance with 450-108. The second part is the quantitative criteria, which is allowed to have an equivalent level of safety. And then part 3 is if a vehicle has sufficient demonstrated reliability as agreed to by the administrator. Next chart. So now we're into the system of prescribed hazard controls. I'm going to go briefly over these because they're going to be covered in much more depth further down in the workshop. Prescribed hazard controls, starting off with computing systems. Part 450's computing system requirements are performance-based, and they levy requirements on computing system safety items in proportion to their criticality. An operator must identify software safety items and their criticality. Software system safety items are any software or data that implements a capability that can present a hazard to the public, and the level of criticality for each computing system safety item commensurate with its degree of control over the hazards to the public and the severity of those hazards. An operator must develop safety requirements for each computing system safety item. An operator must implement and document a development process for computing system safety items appropriate for that level of criticality of the software safety item. Part 450 also requires independent V&V for computing system safety items that meet the definition of safety critical in the new 401.7. Next chart. Safety critical systems, design, test, and documentation. Safety critical systems requirements apply to all safety critical systems with a few exceptions. Safety critical software items are regulated by the requirements in 450-141. Highly reliable flight safety systems, which are regulated by the requirements in 450-145, and safety critical systems for which an operator demonstrates through its flight hazard analysis that the likelihood of any hazardous condition specifically associated with that system that may cause death or serious injury to the public is extremely remote. For all the other safety critical systems, Part 450-143 has design requirements. They must be designed such that no credible fault can lead to an increased risk to the public beyond nominal safety critical system operations. Qualification testing must functionally demonstrate that the design of the vehicle's safety critical systems at conditions beyond its predicted operating environment. Acceptance testing, functionality tested at predicted operating environments with margin, or a QA process to ensure functional capability during its service life. and the life cycle of safety critical systems, to monitor the flight environments, to validate the predicted operating environments, and assess the component life remaining and inspection periods. Next chart. The highly reliable flight safety systems are a special type of safety critical system. And Part 450-145 contains the requirements for the highly reliable FSS used to meet the flight abort requirements in 450-108B1. There are design requirements, which are the flight safety system on board the vehicle has a reliability requirement of 3 nines at 95% confidence and commensurate with design, analysis, and testing. And any ground-based, space-based, or otherwise not on board portion of the system, if any, also has a requirement of 3 nines at 95% confidence, commensurate with design, analysis, and testing. There are monitoring requirements. An operator must monitor the flight environments experienced by any flight safety system component to the extent necessary to validate the predicted operating environment and to assess the actual component life remaining and adjust any inspection periods. You'll notice in some of these slides, we have a gold box at the bottom. When you see that, that is typically a note on the means of compliance. So one means of compliance for 450-145 is RCC 319, the Flight Termination Systems Commonality Standard. Next chart. Other prescribed hazard controls are agreements, to have a written agreement with any entity that provides a service or use of property to meet the requirements in Part 450, including launch and reentry site use agreements, agreements for NOMARs and NODAMs, mishap response agreements with emergency response providers, and the agreements must clearly delineate the roles and responsibilities of each party. Next chart. Safety critical personnel and qualifications and crew rest. These ensure that safety critical personnel are trained, qualified, and capable of performing their safety critical tasks, and that their training is current. Work shift and rest requirements, basically that documents and implements the rest requirements to ensure that safety critical personnel are physically and mentally capable of performing all assigned tasks. Next chart. Radio frequency management ensures that radio frequency interference does not adversely affect the performance of any flight safety system or safety critical system. It also requires coordination for the use of radio frequencies with any site operator or local or federal authorities. For readiness, an operator must document and implement procedures to assess readiness to proceed with the flight, readiness of any vehicle, launch or reentry or landing site, including contingency abort sites, and the readiness of safety critical personnel, systems, software, procedures, equipment, property, or services, and then readiness to implement the mishap plan. Next chart. Communications. An operator must implement communication procedures during the countdown and flight of a launch or reentry vehicle that define the authority of personnel or individuals or position titles to issue those hold and resume and go, no go, and other abort commands. Assign communication networks so that the personnel have direct access to real-time safety critical information required to issue the hold, resume, go, no go, and any abort commands. And to use a defined radio terminology. Communications also ensures that the currency of the communication procedures and that all personnel are working with the approved version of the communication procedures. Another requirement is to record all safety critical communications network channels that are used, whether for voice, video, or data transmissions that support safety critical systems during each countdown. Next chart. Mishap. A mishap includes events that result in fatality or serious injury, malfunction of a safety critical system, failure of a safety organization, operation, or procedure, posed a high risk to occupants or the public, substantial damage to property, an unplanned loss of vehicle, impact of debris outside of the planned landing site or designated hazard area, or failure to complete a launch or reentry as planned. The full definition is in 401.7. A planned loss of vehicle may not be considered a mishap if it was pre-coordinated with the FAA under the optional test-induced damage provision in 450.175. But in general, for all mishaps, an operator must report, respond to, and investigate. They report immediately to the FAA if the mishap involves a fatality or serious injury, otherwise within 24 hours. Also, a preliminary written report must be submitted within 5 days. Respond. An operator must activate emergency response services to protect the public and property, maintain the hazard area, and contain and minimize the consequences of a mishap, and preserve data and physical evidence. Investigate. An operator must investigate the root cause and report the results to the FAA. Next chart. So Subpart D is after a license is issued. It includes terms and conditions for the vehicle operator license, including compliance monitoring, material changes and continuing accuracy, pre-flight reporting, post-flight reporting, and the registration of space objects. Next chart. So that concludes kind of the overview of the safety framework of Part 450. An important aspect of the rulemaking is our plan for existing licensees and companies in pre-application consultation. We call these legacy operators. The rule is effective 90 days after publication in the Federal Register, and legacy operators may operate under the legacy requirements for 5 years after the effective date of Part 450. These operators include existing Part 415, 417, or expendable launch vehicle operators, Part 431, or reusable launch vehicle operators, and Part 435, or reentry vehicle operators. There's also going to be a 90-day transition period. So applicants whose license has been either issued or a license application has been accepted by the FAA no later than 90 days after the effective date of the final rule, which if you're doing the math is 180 days after publication in the Federal Register, would all be considered legacy operators. Legacy license operators must come into compliance on the effective date of the rule on 2 areas: critical asset protection and collision avoidance. And it's important to note that the analyses for both critical assets and collision avoidance are going to be performed by the US government. Legacy license operators may apply to operate under Part 450 after the effective date of the rule. Next chart. Legacy license operators may apply for renewals and modifications. Legacy license operators may submit requests for license renewals such that their license remains valid up to 5 years after the effective date of the rule. If a license expires before the end of the period, an applicant may seek a renewal under the previous provisions of their legacy requirements, but the renewal will only be valid for however much time remains between the time of issuance of the renewal and the end of that 5-year compliance period. Similarly, with modifications, a legacy license operator may modify their license. The FAA will determine the applicability of Part 450 and modifications on a case-by-case basis. The FAA is going to be working with the applicant, and what we're going to be considering is the extent and complexity of the modification, whether the applicant proposes to modify multiple parts of the application, and if the application to modify requires significant reevaluation. Next chart. So in summary, some of the highlighted areas that I wanted to make sure folks had realized we covered is the new Part 450 is flexible. It incorporates the traditional hazard control strategies from both 431 with flight hazard analysis and 415 and 417's flight abort strategy. The high consequence event protection allows flexibility through the equivalent level of safety and also through demonstrated reliability. Part 450 is flexible because it has flexible submittal timeframes. It also uses something called alternatives that can be agreed to by the administrator. Flight safety analysis scope can be based on demonstrated reliability. There's also flexible means of compliance, which provide the industry the flexibility to develop unique means of compliance that meet their objectives. It's also responsive because it relieves duplication for ground safety at certain federal launch or reentry sites. There's also a 5-year compliance period for legacy operators and those with accepted applications. COLA and critical asset analysis will be performed by the US government. Operators can get early approvals through an incremental review of a modular application. And neighboring operations are carved out as a separate category of the public and subject to a less stringent risk threshold as compared to the other members of the public. Part 450 is also streamlined. We think that this can really combine the best elements of Part 415 and 417, as well as 431 and 435 into a single performance-based part to better accommodate the evolving industry. Vehicle operator licenses are valid up to 5 years, and it can authorize operations at multiple sites. We've removed the scope of license that begins at the arrival at the gate, and so it is much more flexible now, and it's based on hazardous pre-flight activities. There's also a new process for seeking safety element approvals in conjunction at the same time as applying for your vehicle operator license. So those are the basic highlights of the rule and an overview. I believe the next up is going to be the pre-application consultation templates and guidance. And I'd like to introduce Mr. Ken Wong. Also, one note on the questions and answers before we get to that. Everything that we covered in the overview, we're also going to cover much more in depth as we dive into each section. So please be patient if we don't answer the detailed questions on the parts. We're going to be focusing this first Q&A session on the pre-app tool templates and guidance. Thank you. Ken, over to you.
Okay, good morning. Okay, the next lead-in, I'm going to be talking about some of the guidance material, which we call like templates and checklists. The bottom line is we're trying to assess applicants, ultimately to be able to submit a complete enough application that the FAA can accept and begin its review. Next slide, please. So the first thing that we're providing is what we call this application letter template. And it's available on our website this morning. And where folks registered for the training webinar, it's basically where the location of the letter template. So this letter template that's been prepared is basically a cover letter that an applicant can easily use and then just tailor it to formally submit a license application to the FAA. So the thing I note about it is this template to prepare this cover letter, it's voluntary. However, the FAA encourages applicants to use it. And the reason being is because we feel like this cover letter template basically contains all the essential parts of what the FAA is looking for in terms of an applicant submitting an application that will be complete enough for us to accept. We understand in the past there's been issues about when is a license application, when it is submitted, when is it considered to be complete enough? So we hope that this template and cover letter will contain those important components about application submittal. Okay, so part of the application letter template will identify compliance documents and any of these FAA approved items that Michelle went over earlier, like alternate alternative timeframes, accepted means of compliance, incremental reviews, safety element approvals. And during this afternoon, we're going to go a little bit further into some of these things like incremental review and safety element approval. However, the major part that we're trying to emphasize is early compliance planning during pre-application consultation. Next slide, please. Okay, so in terms of the cover letter or template we're looking for, there's nothing magical. It's fairly straightforward. Basically, right now it's a PDF document, but easily it could be a Word document, or we could change into a fillable PDF document, very easy. First thing, the cover letter, basically the address, where do you send the application, the point of contact, the address, contact information. Very straightforward. Okay, next. Next slide, please. Also, in the cover letter, we would like, obviously, the company name, identifying or you were the applicant's applying for a vehicle operator's license, either for launch or reentry or both. And then basically an approximate time frame of when the applicant proposes its first launch or reentry. It provides us some feel of the time frame. We can't guarantee we'll meet exactly that time frame, but at least we have a feel while we do the evaluation. The type of vehicle being launched or re-entered. Is it a family of vehicles or vehicle configurations? Because under Part 450, the vehicle operator license allows authorizing a family of vehicles to be launched. Are there any payloads or are there classes of payloads? We would like that to be identified. In terms of the launch site, where is the proposed launch being proposed? And under the Part 450, unlike today's legacy license under Part 415, which is for expendable launch vehicle, the current license only allows a license for a launch from a specific launch location. Under Part 450, under a single vehicle operator's license, an applicant will be able to identify multiple sites from where it's being launched. And also, we would like in the cover letter to identify, does it involve human spaceflight? Are there crew or spaceflight participants on board? Next slide, please. Okay, so as I mentioned earlier, we think the key in terms of making this Part 450 work is early planning and upfront compliance planning. So what we've done in this cover letter is to identify compliance documents that we would like to see as part of the submittal. So this cover letter would basically acknowledge when the applicants submits their application in the cover letter, it would say, hey, this company is submitting for a vehicle operator's license application, and enclosed is a compliance document list. And the next presentation from Annette, she's going to go over in detail what the compliance document list is and what an application compliance checklist is. In essence, compliance document list lists all the application materials that an applicant will provide to comply with the Part 450 requirements. And then this application compliance checklist is a detailed Excel spreadsheet, which Annette will go through, which basically shows compliance from what the applicant will provide to comply with specific Part 450 requirements. And then the next part we would like to see in the compliance letter is this confirmation to meet Part 450.35, which we will talk a little bit later. Under Part 450, there are 5 regulatory sections that we expect applicants to get accepted means of compliance prior to the FAA accepting a formal license application. And these are the 5. They deal with like flight safety analysis methods, toxic hazards, highly reliable flight safety system, lightning hazard mitigation, and toxic hazards mitigations. These 5 need to be accepted means of compliance before we will formally accept the application. So this cover letter lays it all out so it manages expectations of, so before you can get a complete enough license application, you have to meet these 5 accepted means of compliance. Next chart, please. Okay, also, this cover letter will capture any alternative timeframes. As mentioned earlier, Part 450 provides flexibilities in terms of certain timeframes, in terms of submitting application material to the FAA. And these potential alternative timeframes are listed in Appendix A to Part 404. Some of them deal with pre-flight reporting, post-flight reporting, alternative timeframes. So one of the things we would like to do is during pre-application consultations, if there are any alternative timeframes that the applicant would like to propose, or if there are any alternative timeframes that the FAA has already accepted, we would like that documented in that cover letter when the applicant submits their license application. Next slide, please. Also, in the cover letter, we would like it to capture any incremental reviews that an applicant is proposed, and the FAA has already approved the incremental review approach. And we'll talk a little bit more about that later in detail. Same thing in terms of a safety element approval. If an applicant wants to leverage, take advantage of any safety element approval that has been issued previously under Part 414, we would like the cover letter to acknowledge that and document that. Or if an applicant is applying for a safety element approval in conjunction with its vehicle operator's license, which is a new option which is being provided under Part 450. We want that documented. Next slide, please. Okay, the next part is the certificate of accuracy. This requirement is no different than today under the current legacy regulations. Anytime a formal license application is submitted, some person from the company has to be authorized on behalf of that company to certify the accuracy of the application material as being true, complete, and accurate. And in addition, an applicant may describe or request confidentiality treatment of its application material, especially if there is like proprietary information. Next slide, please. And at the end, the enclosures, okay? So as part of the enclosure of the cover letter, we would expect to have this application compliance checklist, which Annette will be presenting, and this compliance document list of all the application material that is being submitted by the applicant. And as noted below, an applicant may file an application with the FAA either by paper, by use of physical electronic storage, or by email. And with that, our next presenter is Annette Parks. Annette.
Good morning. Thank you, Ken. This morning, I will be presenting the application compliance checklist. Okay, great. Everyone should be able to see the checklist. This checklist demonstrated is a draft and it should be available on the website today. The application compliance checklist is similar to previous compliance matrices with some changes. Applicants and operators are encouraged to use this application compliance checklist to have an organized compliance response to Part 450 application requirements, which will facilitate an efficient complete enough determination and licensing evaluation. The organizational format of the checklist is specifically intended to facilitate a rapid, efficient comparison of the regulatory license requirements and the corresponding applicant response, which will in turn save both applicant and government resources and mitigate back and forth during the evaluation. The advantage of this application compliance checklist is, unlike previous compliance matrices, it pulls out all of the application requirements and requires the response only to those requirements. Depending on your operations, there may still be requirements that are not applicable. Let me do a quick walkthrough of this checklist. Here is the compliance checklist overview page, the first tab. It includes a summary of what is included, brief instructions, a legend, and some tips to operate the Excel spreadsheet. Next is the application requirements tab. This is the heart of the application compliance checklist and where the applicant will submit its response to the regulations. This checklist includes Part 413, 414, and 450 application requirements. Part 414 is only required if the applicant is also concurrently applying for a safety element approval with the license application. On the left-hand side, the plus and minus signs allow you to expand and collapse the different headings and sections. The indentations are for part, subpart, subject, section, and licensee requirement. The orange headings are the regulation headings, and if you expand below, you will see the regulation text. We also included these purple headings, and these are expected packages, potentially for incremental review, but they're also useful to highlight the subjects of related regulations. Up top, we have these blue columns, which are the expected responses from the applicant. This first column is the status. This is just to help you know what's open or closed. You can select the drop-down open, which is red, closed, which turns green, or if a regulation is not applicable, you can select NA, which will gray out the entire row. If you select NA, it's also expected for you to note in the compliance notes why it's not applicable. This next column is the compliance notes. This column is where the applicant will identify if the application contains an accepted means of compliance, request for a waiver or equivalent level of safety, the use of a safety element approval, an alternate time frame, why the requirement is not applicable, or any other notes the applicant finds relevant for that particular regulation. The next column is the application material. The applicant is expected to call out the document name or identifier submitted to meet that regulation. I've shown an example here. Now, there may be more than one document to meet the regulation, and the user may include both in the same cell using punctuation, Alt-Enter, or by entering another row. I do want to note that if another row is added, the row can't be deleted without doing Control-Z. The next two columns are to identify the location of the information within those documents. Again, this tool is used to expedite the licensing evaluation process, which is why identifying the specific location of the compliance response is important. If there are multiple documents, please clearly delineate the responses. This last column is to note if the application materials were submitted as part of an incremental review. The applicant should identify the incremental review submittal date and the submission name for tracking purposes. The idea is that this checklist will be a living document that is updated with license updates, modifications, and renewals. I want to reiterate the value of this checklist. The goal is to have the checklist feed into the licensing division's evaluation, accelerating the evaluation process. Additionally, Part 450 allows for increased flexibilities like means of compliance, alternate timeframes, and incremental reviews. And of course, waivers and equivalent levels of safety are not new, but the checklist will help organize and track all of these compliance flexibilities. The responsibility for demonstrating compliance with Part 450 lies with the operator, and this checklist facilitates the applicant or operator's demonstration of compliance more easily and efficiently. Let me go to the next tab, which is all Part 450 regulations for reference. Many of the application requirements reference other regulations within the same section, so this tab is available for quick reference for all of the Part 450 regulations. This sheet also has the expand and collapse functions, and the user is also able to support to filter or sort by regulation type. We have identified the application, post-licensing deliverable, or pre-application approval, but the user can actually change these regulation types for their own purposes. In the final version of this application compliance checklist, we will have tabs for Part 413 and Part 440 regulations so we have all the requirements in one application compliance checklist. Let me go to the last tab. This is the sample compliance document list. This list is available within this checklist and as a separate document. This list assists an applicant in preparing and structuring its license application and is intended to be used in conjunction with the application compliance checklist and application letter template provided by the FAA. This sample compliance document list is an example list of documents the FAA would expect to be submitted as part of the application, and it is one way an applicant for a vehicle operator license may structure its application. At the top here, we have the list of the sample document list. And as we scroll down, we've also included a table that combines the application requirements with the corresponding document. And again, this has the sort or the expanding and collapsing feature. Okay, so the intent of these resources is to expedite the review process, and we look forward to industry's feedback as we implement these tools. Thank you for your time, and I will hand it back over to Michelle Murray.
Thanks, Annette. Next chart. Okay, so we're going to go over another tool that we have, or a checklist essentially. And what that is essentially a meeting agenda. So what are the items we're going to cover in pre-application consultation? There's a few items and I'm going to walk through them. The actual checklist is available on our website, in addition to the charts that you have in front of you. The pre-application consultation meeting agenda, we're going to start off with introductions and give an overview of Part 450. Then we want to hear from the company. We want to hear about your concept of operations, if there's any unique mission aspects, a description of the mission, a description of the vehicle, which sites you're planning to utilize, a little bit about your organization and your program status and desired time frame for launch and for needing a license. Next chart. We also want to see a more detailed program schedule. And we wanted to include your significant milestones, design reviews, any kind of major analyses or reviews that are being completed. We also want to see when you plan to submit application submittals, especially if you're using an incremental type of review. We also want to know when you need that authorization by, whether that's for, ahead of the target first operation for insurance purposes or for business purposes. And then also, what is that target date of the first operation? So that essentially is the program schedule. We also want to know kind of what you think the frequency of interaction with AST would be, meaning Are you going to be submitting things and not needing a response very fast, or are you going to be giving things, submitting submittals on a regular basis and need AST to be responsive to those? The reason why we're asking for that is because we are going to be planning our resources to match the level of responsiveness that you're going to be sending, documents over to us. So just an idea and discussion on that frequency of interaction that you're expecting from AST. Next chart. Program maturity. One of the things that we need to know about your program maturity is so that we know that you can do the types of analyses that are required by the regulations. So we like to know that you have a sufficiently mature and stable design so that you can have those system requirements reviews and preliminary design reviews. And you can tell us about whether you have funding or if you're manufacturing hardware or testing hardware. Those things all help us understand exactly where you are in your program. Next chart. The scope of license. This is a discussion point that we'll have with all operators, and that is to understand, based on the concept of operation and some of the additional information there, where your launch or reentry begins and ends. And that will help you know how to scope your license application. Next chart. And compliance planning. During pre-application consultation, we're going to work with all applicants on compliance planning. And below is a list of the topics that will help with compliance planning that are on our website, the application compliance checklist that Annette just showed a demonstration of, our means of compliance table that's on our website, and I believe I have a screenshot of that coming up. Any unique means of compliance that you're planning to submit, and those 5 special means of compliance that need to be accepted before an application can be accepted, any equivalent levels of safety or waivers that you're planning to submit. Next chart. Now, those first items are essentially for all operators, focused on compliance planning, whether or not you're an experienced operator or a new operator. It's really, what are you planning to do, and when do you need your license, and how are you going to comply? There are some additional optional items, and that's the next set that I'm going to go over. And the Part 450 allows for process alternatives agreed to by the administrator. And for some of the requirements where we felt there was just a need for additional regulatory flexibility without requiring an ELOS or a waiver. In the regulation, as you're reading, you will see the clause as agreed to by the administrator. And for those ones, you will be able to submit an alternative to the proposed requirements for the FAA to review. Again, without an ELOS, without a waiver. Each of those times where you see that special clause as agreed to by the administrator, there should be, finishing that sentence, the basis for which we would approve those. These alternatives will be discussed and agreed upon during pre-application consultation. And again, these are optional. Next chart. Another optional one is the flexible timeframes. So there is always a default timeframe in the regulation. However, if you would like to take advantage of the flexible timeframes, you can propose these alternative timeframes for any of the requirements listed in that Appendix A to Part 404. And again, we expect those to be primarily discussed during pre-application consultation, but we also allow it during the application process or even after a license has been issued through a modification. Next chart. Safety element approvals. This is another one that's not required. It's only if you are either using a safety element approval as part of your license application, or if you're going to be applying concurrently for a safety element approval during your application. If you are planning to seek a safety element approval, you do have to consult with the FAA before submitting that application. There's a pre-application consultation requirement for safety element approvals as well. And what we would look at for that is how is the applicant going to meet the requirements of 450? and the information that is required in 414.13, that you have those, and then the sections of the license application that support your application for the safety element approval. Next chart. And incremental review. So I think one of the great things about Part 450 is that it does allow for this incremental review and approval, and you can submit an application in modules. However, you can't just submit them one at a time without having a plan. So you must have your incremental review approach approved by the FAA prior to submitting the application or the part of the module of the application. What we're looking for again is that they can be reviewed independently and in a workable order under an agreed upon timeframe. The FAA will review each module in accordance with the schedule that you and the FAA will discuss during pre-application consultation. And in developing the incremental review schedule, we're going to be considering those interdependencies as part of the evaluation and the sequence of their submission. Next chart. So again, just to reiterate, the checklist, the pre-app checklist is essentially a pre-app meeting agenda. The first few on the list are things that we expect all applicants, that is very basic: schedule, program maturity, what you want to do, where do you want to do it, and then there's a number of optional items. So the next item I want to talk about in terms of pre-application templates and guidance is our guidance, advisory circulars. The table below contains the Part 450 advisory circulars that have been published to date. We are seeking public comment on these documents. We're asking for a period of 30 days so that we can move these along and issue an updated version if warranted. And each guidance document has a feedback form at the end of it with instructions so that you can actually provide feedback at any time, even after those dates. And that will remain a part of every one of our ACs going forward, so that there is a method to provide feedback. So our first 3 ACs were put on our website on October 15th. And as you look at the means of compliance table, which is again available on our Part 450 website, the means of compliance table has the estimated issuance dates for all the future ACs. So that's where you're going to find the information about what additional ACs are coming up and when do we expect them. That's going to be in your Part 450 means of compliance table. If you go to the next chart, here's a sneak peek of what it looks like there. It is on our website. The Part 450 means of compliance table provides for Subpart C at least one means of compliance for each section as applicable. So you'll see there under Part 450 101, that's not applicable except for the high consequence event protection. And that AC was actually issued again in October 2020. The System Safety Program, Hazard Control Strategy, and Flight Abort ACs are in work, and we expect those to be issued in the first quarter of 2021. Another way to look at this table, there are some other legacy requirements that are accepted means of compliance. So for example, flight safety limit objectives, the legacy regulations in 417 are an acceptable means of compliance. Next chart. We're going to go ahead and start the Q&A session. So I'd like to invite all of the speakers and backup speakers, the backup subject matter experts, to please join me on camera. And we're going to start our Q&A session. So the first question that we have is, will the slides be presented over the next 3 days, and a recording of these sessions be available online afterwards? And the answer to that is, right now, the slides are available on our website. And yes, the FAA is recording this session, and we will make it available. If a new means of compliance is approved that is more efficient than one currently in use under an operator's license, would the operator have to apply for a license modification per 452.11 to be able to use it? Would such a modification be expedited or subject to the same timeframes as any other application? Ken, would you like to take that one?
Yes, the response is yes. If someone wants to propose different means of compliance, yes. It would be under the license modification, yes.
Yeah, and I think that, you know, if somebody is using an accepted means of compliance, that type of evaluation should go a little quicker because we've already accepted that means of compliance. In the case of a foreign launch company using U.S. facilities for launch or reentry, do they have to follow the same rules and application procedures?
Yes, the response is yes. If there's a foreign entity, especially that wants to launch in the United States, they would have to follow the same regulatory requirements. Yes.
Okay. Will safety element approvals and means of compliance submitted by other operators be available to new applicants?
Yes.
I'll take this. So yes, so when an applicant puts in a unique means of compliance, we don't automatically share those with the public because they're part of an application process. If an applicant has a unique means of compliance and they want us to share it with the public, we will. The way we see this happening as time goes on, as we find new and better ways to do things, we'll also update the AC with different means of compliance.
Okay. Does the FAA intend to complete license reviews within 180 days, as is the case today, or is there a possibility for the FAA to complete its review in less than 180 days?
The statutory requirement today, which hasn't changed, is we have 180 days to make a license determination once we accept a complete enough application. That has not changed. In terms of us trying to complete an evaluation quicker than 180 days, we do strive for that as always, but it depends on our resources. It depends on the complexity of the application. It depends if we have all the information that's necessary. But yes, in general, we try to strive to meet 180. We can't always guarantee it based on those circumstances.
And I think one thing that we added in our preamble discussion about incremental review is if you're doing an incremental review and you have modules that have been approved ahead of time, that is an area where we would negotiate and commit to. We can commit to a date that is less than 180 days. And that would be worked out one-on-one with the company as part of their approval of the incremental review approach. The next question coming in is, which division in the FAA will be reviewing safety element approvals?
The division that leads it is the during the reorganization, ASA 100, which is the Safety Authorization Division, they would lead the safety element approval. But having said that, we also have two other divisions. One is ASA 200, which is the Safety Analysis Division. So depending on what that safety element approval entails, if it entails, let's say, flight safety analysis or system safety, then even though ASA 100 is leading it, I could see the Safety Analysis Division also being involved.
Okay. The next question is the Part 450 master spreadsheet available in a read-only format? Annette?
So the draft spreadsheet is available on our website now. In terms of a read-only format, we have it, the 450 regulations all. The cells with the regulation text are locked and are not editable. So it's kind of read-only for everyone. However, the regulation type column is editable and it's filterable or you can sort it as well.
Thanks, Annette. I see there's also a question about whether Part 450 completely replaces and overrides 450, or is this an additional option available to operators? And the answer is the intent of Part 450 is to replace the existing ELV and ROV regulations. However, there's going to be a 5-year compliance period. So those regulations would not be taken out of the CFR or the Code of Federal Regulations until 5 years after the effective date of the rule. We have another question. If a company has been in the pre-application consultation process in 431 for some times, would the company have to go back and complete the Part 450 deliverables and demonstrate it in the new templates if the application date is going to be in the post 431 period? So Ken, this might be a good discussion about the crosswalk tools.
Yes. So we're going to talk a little bit more on Friday when we go into the crosswalk. So if I understand the question correctly, it's asking, is someone who's in Part 431 pre-application consultation under the legacy regulations for over a year, what happens when Part 450 becomes effective? As we'll talk a little bit more on Friday, there's basically two options, okay? The applicant could either continue to seek and apply for a launch license or ROV mission license under Part 431, or the applicant may choose to start applying for an ROV, a vehicle operator's license under Part 450. So the way the Part 450 final rule, it provides that option. Either continue the route to apply under Part 431 or start applying under Part 450. And we'll talk a little bit more about that on Friday.
Okay, so it looks like we have one question about the templates on the website and whether they're going to be in draft form. So what we have on our website currently, we have a number of things on the Part 450 website. We have a posting of the regulation, which has not been published by the Federal Register yet. We have 3 advisory circulars that have been issued and they're open for public comment. We have a number of pre-application consultation templates and guidance, which Ken and Annette and myself have just gone through. And we have the charts from this workshop available, both days 1, 2, and 3. They're all available. And they're all considered draft. Again, we will be updating those as we get your feedback, and we'll be updating those to make them as workable and as good guidance as we can. There's another question coming in about when do we expect Part 50 to be published in the Federal Register? Randy, do you have the latest on that?
Like I mentioned in my opening, we simply don't know. Like I said, I think it's weeks, not months. I mean, there's usually a huge backlog at the Federal Register at the end of the fiscal year, and Part 450 is a relatively long rule because of all the preamble language, and so it might still take a couple more weeks.
Okay. That's all the questions that I see in the queue right now. Any other, we'll wait a couple minutes, see if there's any other questions coming in. So I do see there's a question about the website and where to find those. You can always go to faa.gov/space. And there's a little blue box in there that says streamlining regulation. And you should be able to go there, and that takes you to the Part 450 website, which it's a one-stop shop for everything Part 450, including the workshop materials, the guidance, the regulation, the ACs, all of that. So there's a question, can you explain the timeframes for applications post-publication in the Federal Register? I'm not sure I completely understand that question. So we have, once it goes in the Federal Register, there's going to be a number of dates that are determined based on the publication date, if I'm understanding the question correctly. So we'll have, instead of just saying, 90 days or 180 days, we'll have actual physical dates once the Federal Register publishes. They will change out the insert date here with an actual date. All right, we'll wait another minute, and if there's no other questions, we'll start our lunch break a little bit early. We'll just give it another minute for questions. Okay, there's another repeat question about 450, whether or not it completely replaces and overrides 415 and 417, or is 450 in addition. And again, there's going to be, for folks who are legacy operators, they will be able to, you will have a certain period of time, 90 days after the effective date, to get your the last chance to get your application in as a legacy operator. And there is a short time frame of 90 days where you have a choice to apply under 450 or 415, 417, or 431, or 435. After the 180 days after publication, all applications must be Part 450. And 5 years after publication, the legacy requirements for ELVs, RLVs, and reentry vehicles will be removed from the CFR.
So just to reiterate, so someone who has a current Part 415, 417 license may continue to, if they choose, may continue to operate for 5 years after the effective date of Part 450. They may continue to operate under 450. The only two additional requirements, or two requirements that everyone, whether you're a legacy operator or new operator, is the COLA and the critical asset requirements. All operators have to comply with the Part 450 COLA and critical assets once Part 450 becomes effective.
Okay, and just as a reminder, any questions that we aren't addressing here today, we will address in writing. Some questions that we might be getting are very specific to one company, or just might require a little more reflection on our part before we can respond, and we will do so in writing. Okay, well, with that, I'll conclude this Q&A session, and we have a lunch break from 11:45 to 12:15 p.m. Eastern Standard Time, Universal Cell Phone Time. And so we will see everyone back here at 12:15 sharp.
Discuss Part 450, Subpart A. And first, we want to deal with the applicability. Part 450.1 tells everyone what 450 is applicable to. And I think that it was pointed out earlier in some of the questions in the recent session that applicants with an accepted license application at the time of Part 50 goes into effect may continue to apply for a license to operate under Parts 415, 417, 431, and 435 for up to 5 years after the effective date of Part 450. However, all operators are required to comply with 450.169 for collision avoidance analysis and Part 450.101 A4 and B4 for critical asset protection once Part 450 becomes effective. So in other words, those parts need to be complied with 90 days after the publication of the NPRM, of the final rule in the Federal Register. So operators currently holding an active valid license will have 5 years after the effective date of this rule to come into compliance with the entirety of Part 450. And if the license expires before the end of this period, an applicant may seek a renewal under the previous provisions, but the renewal will only be valid for however much time remains between the time of issuance of the renewal and the end of the 5-year period. Legacy licenses may be modified, and whether new license modifications need to comply with Part 450 is subject to FAA approval on a case-by-case basis. Next slide, please. So Part 450 doesn't make any immediate changes to Part 401.5. That's where the definitions are located. Part 405 will remain in effect for 5 years after the effective date of Part 450, and its definitions will be applied to existing Parts 415, 417, 431, and 435. But after 5 years, Part 401.5 will go away and be replaced by Part 401.7, which will be active for anyone who's going to apply under a Part 450 license. Next slide, please. So in the final rule, the definitions from Part 401.5 are adopted as new definitions specifically applicable to Part 450 requirements. The new requirements contain most of the proposed definitions from Part 401.5. In addition, 401.7 doesn't contain the definitions for federal launch range and launch site safety assessment. Those definitions already are in Part 401.5. The reason they're not in 401.7 is that we no longer use them in the regulations. The FAA adds new definitions, which include critical asset, critical payload, disposal, flight abort, hazardous debris, key flight safety element, neighboring operations personnel, and useful mission. Next slide, please. So next we're going to discuss what comes under a license. And Part 405.3 discusses the scope of a license that we're now calling a vehicle operator license. So it replaces both the launch licenses under Part 415 and 431 for reusable launch vehicles, or reentry licenses under Part 435. So what does it do? It replaces those with one license, which we're going to call a vehicle operator license. So what does it authorize? Vehicle operator license authorizes launch, which includes the flight of a launch vehicle and pre-flight and post-flight ground operations. These things have not really changed significantly, with one exception from what is the current practice under the legacy regulations. And that big change is that launch begins now when hazardous pre-flight operations commence at a U.S. launch site that may pose a threat to the public. And hazardous pre-flight operations include pressurizing or loading of propellants into the vehicle, operations involving a fueled launch vehicle, the transfer of energy necessary to initiate flight, or any hazardous activity preparing the vehicle for flight. But they don't include the period between the end of the previous launch and launch vehicle reuse, when the vehicle is in a safe and dormant state. And what that does, it recognizes the change that's occurred in the launch industry, where we are moving towards more and more reusability of vehicles and components of vehicles. At a non-US launch range, launch site, I should say, launch begins at ignition or at first movement that initiates flight, whichever occurs earlier, and that's current practice. It's important in pre-application consultation with the FAA to work out when exactly launch is going to begin. What are the hazardous pre-flight operations that will trigger the need for a license? Next slide, please. So these, when launch ends, really hasn't changed in any meaningful way from the existing regulations. For an orbital launch of a vehicle without a reentry of a vehicle, it ends after the licensee's last exercise of control over its vehicle on orbit, or after the vehicle component impact or landing on Earth, after activities necessary to return the vehicle or component to a safe condition on the ground after impacting or landing, or any other activities necessary to return the site to safe condition, whichever occurs at the latest time. For orbital launch of a vehicle with a reentry of the launch vehicle, launch ends after deployment of all payloads upon completion of the vehicle's first steady state orbit, if there is no payload deployment, after vehicle component impact on landing or Earth, after activities necessary to return the vehicle or component to safe condition on the ground, after impact or landing. I think it's important to note that we've used the word impact or landing. And what that does, it recognizes the two things that can happen with a vehicle. One is impacts, say, of a spent stage. The other is a planned landing of a reusable type launch vehicle. For suborbital launch, and this is one that people always wonder, why in the world do we have this definition? For a suborbital launch that involves a reentry, launch ends after reaching apogee. And the reason for that is, it's generally speaking, a suborbital launch is always going to have a reentry, but normally, for a suborbital launch, it doesn't include a reentry. Launch ends after vehicle or vehicle component impact or landing on Earth. What this does is it allows for the possibility, this number, the 3I component of this requirement, allows for the possibility of a vehicle that is being launched from a foreign country, for instance, and then re-enters into the United States. That's why that definition exists, not definition, but requirement. But these requirements aren't any different than the current requirements. They're just phrased a little differently to capture and try to make generic the requirements that exist currently under Part 415 and Part 431 for reusable launch vehicles and 435 for reentry vehicles. Next slide, please. So we've already mentioned this, that Part 450 requires an applicant intending to launch from a U.S. launch site to identify pre- and post-flight ground operations such that the FAA is able to determine when the launch operation should begin and end. And this requirement only applies to launches from U.S. launch sites because, as we said, from a foreign launch site, the launch begins at ignition or first movement that initiates flight. Next slide, please. So this requirement just consolidates the requirements for different types of launch and reentry licenses in parts 415, 435, and 435 into a single vehicle operator license that authorizes operations at multiple sites. And that is one of the differences between this and Part 415, for instance, because Part 415 only allows a license to cover launches from one site. Part 431 does allow the possibility of launches from multiple sites under the rubric of one license. So this is basically just a consolidation of existing requirements with the addition of including the possibility of a license covering more than one launch site. Next slide, please. So what's going to be the duration of a vehicle operator license? It's going to be as long as 5 years, but not more than 5 years. We considered setting all license durations at 5 years, but we rejected this because we thought that in some instances, an operator may wish to have a license that doesn't last for 5 years because there are certain requirements, obligations that a licensee has to meet when holding a license. So, but in general, for what we now would consider operators' licenses, our intent would be that most licenses would be good for 5 years. And just as today, licenses are renewable. Next slide, please. Additional terms and conditions for a license. The FAA can modify a vehicle operator license at any time by modifying or adding license terms and conditions to ensure compliance with the Act and regulation. This is just a consolidation of existing requirements from Part 415, Part 431, and Part 435. Next slide, please. So while we were working on the final rule, we recognized that we actually had more specific requirements for a transfer of a vehicle of a license of a safety, what we're now calling a safety element approval, than what we did for the transfer of a license under either Part 415 or Part 431 or Part 435. This just provides clearer guidance as to what's required to transfer a license. It doesn't change, in fact, any of the requirements of a license transfer. Some of these requirements, I think, are obvious, that we're the only entity that can transfer a license, and that either the holder of a vehicle license or the prospective transferee may request the transfer. And both the holder and prospective transfer must agree to the transfer. An applicant for a transfer of vehicle operator's license must submit a license application in accordance with Part 431, Part 413, I mean. And the FAA will transfer a license to an applicant that has obtained all the approvals and determinations required under this part for a license. We can certainly incorporate by reference any findings made part of the record to support the initial licensing determination. And the FAA will provide written notice of its determination to the person requesting the vehicle operator transfer. In the past, when we've transferred licenses, we've supplied them with a new license. We've usually maintained the existing license ordered numbers and license number for convenience, and given out a new license which shows the new license holder on the license. Next slide, please. So what doesn't a license do? Well, the existing parts make it clear that there are certain rights that aren't conferred by the issuance of license. And one of the things that a license doesn't do, the most important thing is, it doesn't relieve a licensee of its obligations to comply with all applicable requirements of law and regulation. That would include state laws and local laws as applicable. And certainly any requirements by other federal agencies that relate to the launch or to anything else, such as the FCC requirements for frequencies and NOAA's requirements for remote sensing. Next slide, please. I think we're questions and answers. Michelle, any questions?
Yes, welcome back. We have a number of questions lined up, Phil and Ken. After a license is issued, can it be modified to add additional launch locations or an additional range?
Yes. Do you want to add anything, Ken, to that? I think it can be modified just as our existing licenses can be modified. But as I pointed out, Part 415 doesn't allow multiple launch locations. Part 450 does.
Right, and I think to add to that, I think that is one of the big purposes or one of the big goals of Part 450. Part 431 allowed additional launch sites. Part 415, 431 did not allow. And so, Part 450, we wanted to bring the best of both sides and allow one license to have additional sites and multiple sites be authorized under one license. Okay.
And hopefully a lot of the application material that's relevant for one side is also relevant for the other sides, particularly information about the launch vehicle or the reentry vehicle.
Yeah, absolutely. Let's see, it says for 453B, for a US launch site, there is a clear definition. For non-US launch, just for clarification, does that mean a launch on non-US soil, as in a foreign country, or does it refer to a non-US government site, like a non-NASA DoD?
It refers to launch from
and how about for US territories?
Don't think we've ever had a launch from a U.S. territory, but I think we would consider that a launch from the United States. I think that's the way the law works relative to that. In the question of a foreign launch site, it would be a foreign launch site as compared to a commercial launch site within the United States. A commercial launch site within the United States is treated essentially the same way that a launch from a federal launch site would be treated.
Right. And
relative to that, relative to when launch begins and ends.
right. And I think the main point there is that for a non-US launch site, launch begins at ignition. For a US launch site, we have the ground safety and the pre-flight hazardous activities that are also included under the definition of launch. I think a lot of folks don't realize that launching, the definition of launch is not the layperson's definition of launch. Our definition of launch includes pre-flight activities, the flight itself, and post-flight activities. Okay, so there's a question, and Phil, I might go ahead and answer this one because I had a chance to take a look at it, so you won't be put on the spot immediately. On chart 76, it asks if 3 and 4 are switched, and what that is if there's a reentry, surely you'd want to consider the proposed landing to be one of the components of launch ending. But as slide 76 is written, that's only if there's no reentry. I think to clarify, under 450.3b, 3 and 4, 3 is for a suborbital reentry without a suborbital launch without a reentry, and then 4 is a suborbital launch with a reentry. And when you don't have a reentry, you have the launch and landing, but it's not a reentry. And then for the other one, it is the suborbital launch with a reentry, and so you have launch and reentry.
Correct.
Okay, next question is, what is the standard for license modification? If we license under 415 and 417 and then modify the vehicle or operations, what will be the trigger to having to switch to Part 450?
I think that was discussed in the preamble to Part 450.
Yeah, and I covered that on some of my overview charts as well.
I think that we envisioned that modifications would be allowed under the legacy requirements in general, unless it was something that was fairly radical that would trigger the need to invoke Part 450. But the types of modifications that we typically see today would probably be allowed to continue to be made under the legacy requirements. Ken, do you want to add anything to that?
No, I think you captured it. Yes, you captured it. But as we said before, and it's noted in the preamble, we will look at it overall, the complexity, how much the license mod is, because there are certain cases where there's a license mod where it almost entails a complete license application evaluation. And one of the things that is we're trying to point out here under Part 450 is Part 450 provides a lot more, we believe, a lot more flexibilities and options. So if there are cases where someone currently under a legacy license has a operator's license and wants to modify an existing license for a brand new type of vehicle, new trajectory, and in essence, even though they're authorized to seek a modification under the legacy license, but in terms of the groundwork in the evaluation, sometimes it's almost like evaluating a complete a new application. And what we're trying to say here, if an applicant or an operator is going to go to that extent for a major modification, why not try to take advantage of the flexibilities and under Part 450, plus 5 years later, everyone's going to have to operate under Part 450. So it'll be like a case-by-case basis where the FAA will work with an existing operator during a license modification. It's probably the best answer.
Exactly.
Yeah, I think one of the things we noted in the preamble was the extent and complexity of the modification and whether the applicant proposes to modify multiple parts of the application. And then, as you guys have both mentioned, if that modification requires a significant amount of re-evaluation. So like you said, Ken, if it's like a whole new license application where we have to go through basically every part of the application, like a domino effect, and you have to, it's revising many parts, that might be something we would consider.
Okay.
Okay, we have one more question in the queue right now, and that is a transfer of a single vehicle operator's license restricted to FAA-approved licensed spaceports, or can a license be extended to non-FAA-approved planned spaceports or non-US ranges? Ken, did you want to take this one?
I think,
no?
sure. I think the answer is a transfer. A transfer in and of itself assumes that nothing much is changing relative to the operation. That doesn't mean, however, that the license couldn't be modified to allow those changes. But remember that the existing legacy licenses, certainly under Part 415, would not allow a transfer to a different location. But 450, if one were under this, transferring a license under 450 to a different location would be something that could be done, but that would be looked at, I think, as a modification to the license, and the transfer would be another action. But they could be done simultaneously.
Yeah, and I think part of the question was about whether it could go to a planned launch site. And there was a little bit of a clarification brought in there that it was thinking about like an exclusive use or private site. And I think the answer is yes. You can modify a Part 450 license for additional sites, just blanketly additional sites. But if you're going to what will be eventually a licensed site, I think that the site would have to have its license before you could conduct operations there. Okay, do we have any more questions coming in? I don't see any in the queue. We'll wait another minute or so.
I think, Michelle, this is kind of related, that it's possible to, if one is operating under an legacy license and one wants to transition to a license under Part 450, one could apply, an applicant could apply for a transfer to license for a 450 license, but at the same time, they would continue to be able to operate under the legacy license as long as the representations and conditions of the legacy license were observed.
Yeah, absolutely. Let's see. I don't see any other questions coming in. We're about 2 minutes early. I think one of the things I wanted to just reiterate was on the scope of license, there is a lot of flexibility on that. When you look at the regulations in 450.3, they have that agreed to by the administrator so that you have the guidelines of when launch begins and ends for all the different types of vehicles, suborbital, orbital, when reentry starts and stops. But if there's something unique that doesn't take into account Part 450, being very flexible, there is another option if agreed to by the administrator to tailor that very specifically to your operation. And that's one of those agreed to by the administrators in 450.3. Okay, well, let's go ahead and if there's no other questions, let's get the screen sharing back up so that we can go into Subpart B. We'll wait just a second. We want to try to stay on schedule as best we can. But Subpart B is generally the requirements to obtain a vehicle operator license. And Mr. Ken Wong will be presenting this section. Go ahead, Ken.
Okay, thank you, Michelle. Next slide, please. Okay, so as Michelle mentioned, Subpart B is basically the requirements to obtain a vehicle operator's license. So the first thing to obtain a license is there's certain components. There's the policy approval, favorable payload determination, a safety approval, environmental review, and MPL satisfying MPL information. All these approvals and review requirements currently exist under the legacy parts. So none of that is new. Okay, so then we go under 450.31B Bravo. Okay, same thing. It says all the things that I just mentioned, the policy, the payload, the environmental, the MPL. Even today, an applicant may apply for these approvals and determinations separately and independently. That's allowed today. So what is different under Part 450? You can do the same thing under 450. But if you go under 450.31 Charlie C, okay, the difference, as we keep trying to hammer out, and I know through the training, sometimes we're repetitive here, but we're trying to reiterate the important facts. So under C, Charlie, an applicant may apply for a safety approval in an incremental manner. That is different today under the under 450 when it becomes effective. In essence, what it means is part of the application, license application, the safety review part, the flight safety analysis, the system safety, the ground safety, prescribed hazard, it's one of the biggest, it's actually the biggest part of the review. So this 450 provides the opportunity to minimize regulatory uncertainty where an applicant may apply for a portion of the safety review, a part of their application. It may be just flight safety analysis. It may be just system safety or ground safety, a portion of it, and get advanced approval of a part of a safety review. Okay, so that's a major aspect. Next slide, please. Okay, this pictorial, and I think we may have seen it under Michelle's overview, but basically the vehicle operator licensing process in general, in simple terms, it hasn't really changed from the legacy. You still have the pre-application consultation that we talked about. As I mentioned earlier today, we are going to really hammer and focus and emphasize during pre-application consultation compliance planning up front. Okay, and then in the middle, the different major components, the policy review, payload review, safety review, MPL, which is maximum probable loss, environmental determination, those are still under Part 450. They don't go away. And then if we were to issue a license or permit, afterwards, there's post-licensing requirements, and then there's safety inspection, which is like compliance monitoring, and that's not different. Next slide, please. Okay, the next thing I want to do is go into a little bit more detail in terms of what this incremental review that we talked about. Okay, so one of the things we had to do under section 413.1, okay, under part 413, it's the requirements sections. 413 is when for the requirements for applying for a license. And one of the things we had to amend the 413.1 is make it clear now that, hey, an applicant now has a means to provide a portion of its application for the FAA to review. And that's what Section 413.1 clarifies, okay? And also an important aspect under the incremental review, as shown in the chart here, 450.33 Bravo, is this incremental approach must be approved in advance by the FAA. And the reason we have to make sure that the FAA approves of this incremental approach is because we don't want an applicant submitting portions or modules of a safety review if it's not in a workable chronological order that the FAA is able to review independently. That's why we need this incremental approach approved in advance. And we are committed to work with applicants during pre-application consultation to work it out and have the discussion. And once an incremental review is submitted by an applicant, another different thing is the FAA then will make an incremental determination on that incremental review. And we would most likely document that and send a letter back to the applicant after we finished our incremental review. Next chart, please. Okay, the next thing I want to talk about are some viable candidates for this incremental review. As I talked about earlier, remember, incremental review, that what we're talking about here deals with the safety review. Because as I mentioned earlier, today, sometimes it gets mixed up. We talked about, like, as I mentioned earlier, a payload review may be assessed independently or separately, okay? So what we're really talking about here under Part 450, incremental review, we're talking about the safety review part, okay? So having said that, what are some of the viable candidates that we see for incremental review? Some of it could deal with a system safety program, hazard control strategy, flight safety analysis methodology, flight safety system design. So for example, like today, if an applicant has a flight safety system, their design, what they're thinking about, they can come to us under Part 450 per some of the regulations and say, hey, FAA, can you review my flight safety system design per these Part 450 regulations? And if we agree to, then we would do an incremental review of the flight safety system. And then after our evaluation, we would make an incremental determination. And if it's thumbs up favorable, we would send a letter back to the applicant and say, yes, we issue an incremental determination. And if it's favorable, then later on, downstream, when the applicant is ready to submit a complete license application to the FAA, then we will have already reviewed that part of the flight safety system, okay? So that part will expedite the evaluation, okay? So in addition to these viable examples of potential incremental review candidates, the next thing we show is figure 1. Next chart, please. As you've seen, this is basically the safety framework under Part 450, as Michelle went over earlier today. So basically, what you see here and the regulations pretty much provides sample candidates that can be used for an incremental review. And I'm not going to go into detail, but these are sample candidates. Next chart, please. Okay, So we've discussed a lot about incremental review candidates. So really, at the end, what is really the benefits? Okay. So the big benefit that we see today is a lot of times when an applicant is submitting a license application to us, especially the safety review part, there's a lot of parts under the safety review: the flight safety analysis, the flight safety system, the ground safety, the hazard controls, hazard analysis. And a lot of times an applicant doesn't have all that information for all those major safety review components. However, they may have certain portions of their safety review applications that are ready. So under Part 450, this option and flexibility allows an applicant not to wait till they have their entire safety review application part. They can just pick some portions or modules and submit those completed parts and submit that to the FAA for review. Okay, and as I mentioned earlier, one of the things we've heard is it can buy down regulatory uncertainty if an applicant can get some advance or early buy on certain major components. Okay. But having said that, as I mentioned earlier, not everything can be feasible as an incremental review, because certain things have to be submitted in a workable chronological order. As shown here on this chart, one example would be like for a flight safety analysis or risk analysis. Before you can do that, you need a debris analysis or probability of failure. And if you don't have a debris analysis or probability of failure, it may be too early to submit the risk analysis. That's just one example. But as I said before, we will work closely with the applicant during pre-application consultation. Next chart, please. Okay, so in terms of the review period, so there's some questions that I know applicants out there, operators out there, and says, okay, what is the review period for this incremental review? Is it going to reduce my 180-day, which is the statutory requirement that we discussed earlier this morning? Today, by statute, the FAA has 180 days to make a license determination once we accept a completed application. So what we said in the final rule preamble, we said that, and also in the regulation that we amended under 413.15, we said the FAA will establish the time frame for any incremental review and the determination with an applicant on a case-by-case basis during pre-application consultation. So I wish we had a better answer than case-by-case, but as I said before, we will work with the applicant during pre-app to try to come to an agreed upon schedule, workable schedule. Okay, next chart, please. So also there have been questions about, okay, when does this 180-day clock start? The way today it's written is for us to formally initiate the 180-day clock to make a license determination, that's when we receive a complete application. So someone who just submits a portion of the safety review would not initiate that formal 180-day clock. Okay, so an incremental review would not formally initiate that 180-day review period. However, as I mentioned earlier, we would work with the applicant to come to an agreed review period and time frame in terms of reviewing the incremental review. Okay, next chart, please. Okay, the next subject is means and compliance. I think personally the crux for Part 450 to work, and also for our existing legacy regulations, but especially Part 450, is means of compliance. And I keep trying to hammer down the point, means of compliance. So this morning, earlier, we talked about the application letter template or the cover letter, which will be used to submit a formal vehicle operator's license application. So as I mentioned earlier this morning, we really want to emphasize upfront means of compliance. So as mentioned earlier this morning, these 5 sections, I'm not going to repeat it, these 5 sections, an applicant has to have an acceptable means of compliance approved by the FAA before the FAA will accept a license application as complete enough. These 5 sections must be, means of compliance must be accepted upfront. Okay. And also, as you see in gold, we will have an AC that will explain in more details on how to comply with Section 450.35. Next chart, please. Okay, this table here is basically accepted means of compliance for these 5 sections that I talked about earlier. And I'm not going to repeat it there. It's on in the charts here for everyone to see. And I believe it's on our website also. Okay, next chart, please. Okay, so in terms of means of compliance, so the next thing I want to talk about is unique means of compliance. So the FAA has tried to help industry by providing a table of what, as of today, what we have found to be acceptable means of compliance. But at the same time, Part 450 provides the flexibility where an applicant may propose unique means of compliances, okay? But also, Part 450 allows, outside of the licensing process, other proposed means of compliances may be proposed. And these outside of the licensing process, these other entities that may propose other means of compliance would include standard organizations. Voluntary consensus standard bodies would be an example, okay? And for the means of compliances, except for the means of compliances, the FAA would provide a public notice of each means of compliance that the FAA has accepted. Okay, next chart, please. Okay, the next thing I want to talk about is just very briefly is equivalent level of safety. That's one of the regulatory tools that's available today. You have equivalent level, you either meet the regulation or you can demonstrate an equivalent level of safety, or an applicant or operator may request a waiver. So the provision for equipment level of safety also exists today under the legacy parts 415, 417, 431, and 435. And we have retained it under 450. So basically, the definition of equipment level of safety means an approximately equal level of safety as determined by qualitative or quantitative means. That definition, even though it's under 401.7, it's also a definition that exists under the legacy parts, and that definition hasn't changed. Next, please. Next chart. Okay, the next thing I want to talk a little bit is the safety element approval that we today talked at multiple times earlier this morning, but wanted to provide a little bit more detail, especially those that may not be familiar with safety element approval. A safety element approval is something that is voluntary today, okay? And it's under Part 414. It's voluntary, and I'm going to explain a little bit about it. But one thing I want to mention is we change under Part 450. We are changing the definition of or the term safety element approval. Today, under Part 414, we use the term safety approval, but it gets confusing when we talk about safety approval, because under a license application, when the FAA conducts a safety review, and then when we make a favorable safety review determination, it's also called a safety approval. So to distinguish that from this thing we're talking about, a safety element approval, we are using the term safety element approval when we are talking about Part 414. Okay, so in essence, let me just explain simply what a safety element approval. A safety element approval, and this is no change than what we currently have under Part 414. A safety element may be an entire launch vehicle, even though today we haven't done a safety element approval for entire launch vehicle, but it's allowed. It could be an entire launch vehicle, re-entry vehicle. It can be a safety system. It can be a process. It can be a service, okay? Or any identified component thereof and qualified. And it could be trained personnel performing a process or function related to a licensed activity or vehicle, okay? And who's eligible to apply for a safety element approval? It could be a designer, manufacturer, or it could be a launch operator. Okay, today, for the safety element approvals that we have issued, and if you're interested to see what safety element approvals we have issued today, they currently exist on our FAA AST website. To date, there has been no launch operator that has applied for a safety element approval, okay? But to encourage under Part 450 for launch operators to also take advantage of safety element approvals, we are allowing under Part 450 that an applicant, a vehicle operator license applicant, may also apply for a safety element approval in conjunction with a license application. Next chart, please. Okay, so how does one apply for a safety element approval? There are two options. One is apply under Part 450, 414.13, which is separate from a vehicle operator's license. The other option, as I mentioned earlier, is for an applicant, when they submit a vehicle operator license application to us under 450, we are providing the option for the applicant, launch operator applicant, to also, in concurrence with their application for their license application, to also apply for a safety element application and leverage on some of the same material that is applicable under the license application to apply to also the safety element application. Next chart, please. Okay, this chart basically just summarizes the safety element approval eligibility that I talked about. So even the statute today talks about safety element. So safety element has been around for a long time. As I said, it could be a vehicle, it could be a process, it could be a service, it could be personnel, okay? But whatever, it has to be linked to one of our regulatory requirements, okay? The safety element has to be linked. And I'm gonna go into just a brief example. Okay, next chart, please. Okay, so this here, the chart, and I'm not gonna read it, basically just identifies under Part 414 that if someone's trying to apply for a safety element approval, it just links them to the applicable Part 414 requirements. So let me just give an example of a safety element approval, okay? And this just is an example. Let's say there is a flight safety system. Someone has designed a flight safety system, okay? A company has designed a flight safety system and wants to offer their flight safety system to different operators, different launch operators, okay? So that company that designed and built the safety, built the flight safety system, comes to the FAA, applies for a flight safety system and says, this flight safety system can operate under these environments: shock, thermal, vibration, and there's a certain envelope that it can operate under, and they can fulfill certain FAA requirements, okay? And if the FAA issues a favorable safety element approval, they would issue that safety element approval to that company with the flight safety system. So the benefit is, in the future, if there's another company is applying for a launch license from the FAA and wants to utilize and say, I'm using this flight safety system, they can leverage that safety element approval, mention that in their license application and say, on my vehicle, I'm using that flight safety system that meets those requirements under the safety elements, under that scope, under that operating environmental. And given that, we will not re-evaluate that flight safety system, those parts, the environments, everything that cover the safety element approval. And that's the benefit of the safety element approval. Okay, this chart here, I'm not going to go in detail, is the requirements under 414 that the FAA would be using to evaluate a safety element. Test and evaluation procedures, test results, and different types of analyses. Next chart, please.
I think at this point, we're going to switch over to Phil Brinkman for the policy review.
Okay, Michelle. So we currently, under our existing parts, 415, 431, and 435, conduct a policy review. And basically what we've done is to consolidate in under Part 450.41, the policy reviews that we currently conduct with a couple little nuances. But it's important to point out that the purpose of a policy review is to determine whether the launch or reentry proposal would potentially jeopardize U.S. national security or foreign policy interests or the international obligations of the United States. And because of the importance of these outcomes, we ask additional questions if necessary, additional information from an applicant to support our interagency consultation. The interagency partners who we consult with include the Department of Defense, the Department of State, NASA, and we also consult with other government agencies as required. Next slide, please. So if issues arise during our policy review, we will advise the applicant in writing of those issues. And we would work with our interagency partners and with the applicant as appropriate to attempt to resolve those issues. That's why we may have to ask for additional information. If we deny a policy review, we also notify the applicant in writing. Next slide, please. So here's an example where we've maybe improved Part 450 over the existing legacy requirements. The legacy requirements required an awful lot of information about the structure of the launch vehicle or reentry vehicle, pneumatics, propulsion, electrical systems, thermal guidance, avionics. All these were spelled out in the application requirements for a policy review. And yet, in looking at it, we didn't think that those requirements were really the kinds of things we and our interagency partners needed to look at in order to determine the foreign policy, national security aspects of the operation. So we've simplified those requirements. Those requirements now are where they belong in the safety review, and we've simplified them by taking them out of the policy review application requirements and replacing them with basic information such as basic information on flight azimuths, trajectories, sequence of planned events, normal impact and landing areas, and for orbital missions, a range of intermediate and final orbits of each vehicle upper stage and their estimated orbital lifetimes. Estimated orbital lifetime is in the existing regulations, by the way. Next slide, please. So, important points to remember that that we considered whether it was worthwhile to try to come up with explicit criteria. And we determined for a policy review, we determined that it really wasn't possible because we couldn't anticipate the full range of issues that might arise. And the importance of those issues, national security and foreign policy issues of the United States, would argue against limiting our ability to look at policy considerations. That said, historically, few issues have arisen during policy reviews. Next slide, please. And I should mention that that a policy review can be applied for separately from a license application, but it must be the launch operator or reentry operator. The vehicle operator must be the applicant for a policy review. But under the legacy licenses, it could be applied for independently, and also under Part 450, it can be applied for independently. Of course, if you don't have a payload, you don't have to do a payload review. And we've made that clear in Part 450. I don't think it was clear in the, as I recall, in our legacy requirements. We did make a significant change relative to payload reviews from our legacy requirements. In our legacy requirements, it says we don't conduct a payload review for payloads that are licensed by the Federal Communications Commission or by NOAA, by the Department of Commerce. But in reality, in practice, we have conducted a payload review. And so we've corrected the language in the regulation to indicate that we don't conduct a payload review on those aspects that are regulated by the Federal Communications Commission or the Department of Commerce. And we don't conduct a payload review in looking at the national security or foreign policy aspects of the payload if it's a US government payload either. However, we always look at the safety implications of a payload relative to the launch of the payload and the reentry of a payload if it were returning, for instance, as part of a cargo in a reentry vehicle. Next slide, please. So just as with a policy review, we consult with our interagency partners, Department of Defense, Department of State, and other federal agencies, including NASA. The FAA may review and issue findings regarding proposed class of payloads, including communications, remote sensing, or navigation. However, prior to the launch or reentry, each payload is subject to verification by the FAA and its launch or reentry that it would not jeopardize public health and safety, safety of property, U.S. national security, or foreign policy interests of the United States, or obligations of the United States internationally. It's important to keep in mind that that the payload operator or the payload owner may apply for a payload review independently of a license. So here, as is a little different than for the policy review, where only the vehicle operator can apply for the policy review. Here, either the vehicle operator can apply for the payload review, or the owner and operator of the payload may apply independently for a payload review. In general, this just consolidates existing requirements with a couple caveats, a couple additions that we'll go into on a future slide. But the FAA, I think it's important to note that currently, in addition to the Department of Defense, State, and NASA, just as with a policy review, we also consult with the Department of Commerce, the Federal Communications Commission, the Office of the Director of National Intelligence, and the United States Coast Guard. But we can add other agencies as required. Next slide, please. So again, just as with a policy review, we can ask for additional information that might be necessary to make a determination. And just as is the case with the policy review, for a payload review, there are no explicit criteria other than the overarching criteria that we've mentioned of national security, foreign policy obligations, et cetera, of the United States. And again, if we issue a payload determination, a favorable payload determination, if it's not part of a license where it's clarified in the license and the license orders that what payloads are authorized or what generic types of payloads are authorized, we issue a letter to the applicant with the payload determination. And we've done quite a few independent payload determinations. Usually it's from an operator who has a unique payload and wants to be assured that there are no issues that would preclude its launch. So in those cases, a payload operator has often come to us requesting an independent payload review. Once a payload determination is made, as long as nothing changes, then that is incorporated in any license that would involve the launch of that particular payload, and we would not readdress the issues that were raised during the payload determination if it had been done independently. Next slide, please. So there are these requirements are in general the legacy requirements in our existing regulations, but we've added a couple additional requirements that we don't really think are a particular burden to the operator. That would include the composition of the payload and any hosted payloads anticipated, the anticipated lifespan of the payload in space, any planned disposal, and any encryption associated with data storage on the payload and transmissions to and from the payload. Those are the new requirements that are in the Part 450 requirements. Typically, when we've received payload review requirements currently, as I said earlier, we can request additional information as necessary. And these are things that our interagency partners have been particularly concerned with. It should be noted that these are informational requirements. There's no explicit requirement saying that encryption has to be done. I think that most payload operators probably want to encrypt their data so that no nefarious acts can be done against them or against anyone else. But in general, with these exceptions, the payload requirements are very much the same as the existing requirements under the legacy regulations. Next slide, please. Michelle, do you want to add something?
Yeah, I just wanted to see if we can move along a little bit quicker. We're into our Q&A time.
I'll try.
Thanks.
So for reentry, we also have payload requirements, and that's basically going to be a payload that's reentering as cargo on a reentry vehicle. Those requirements are a lot less stringent because obviously the payload was already in orbit and it's just coming back in a way. And this would not be for the reentry of a payload in an uncontrolled way for the disposal of a payload, by the way. This is a returning payload on a reentry vehicle. Next slide, please. So I think we've already said this. In the interest of time, I will pass over this slide. Next section is on safety review and approval. That's really the bulk of what we do. The most important aspect of our office is to maintain public health and safety. We have performance-based regulations that allow an operator to use, we think, in almost every instance, DoD and NASA practices as a means of compliance. In addition, this rule introduces a provision that allows operators operating from certain federal sites to opt out of demonstrating compliance with ground safety. And as mentioned, I believe this memorandum, this agreement was posted on our website and was signed by General Moncrief just within the last few days. Next slide, please. So again, this is just a little discussion about how we approve the assess a federal launch or reentry site and determine that the federal site meets FAA safety requirements. This is very akin to what we do today. Next slide, please. This is a really busy chart, so it's probably best to read it and not for me to read it in detail here, but it's generally goes through application requirements as to what the applicant must submit, including some basic information such as glossaries and equations and reference materials, a site description, a vehicle description, which is certainly far more detailed. Next slide, please. Again, we can do a safety approval, an applicant, we can do a safety approval, review approval under the legacy regulations. And I think one company actually did maybe 25 years or 30 years ago, close to 30 years ago, a safety review approval that was done separately from a license approval. But again, this just gives the various requirements in terms of mission schedule. If human spaceflight is involved, it's necessary to comply with various parts of Part 460. If radionuclides are involved, we're going to evaluate those on a case-by-case basis. And any additional material that we need to ask for, we ask if it's necessary for to determine public health and safety. Next slide, please. Environmental review. This really hasn't changed from the existing regulations. What's changed is that we've clarified it in this regulation by providing more detail. We work very closely with applicants relative to the environmental review, and environmental review is something that's required for any major federal action under NEPA, and licensing, permitting are major federal actions, and they invoke the need for an environmental review. But again, this does not change existing requirements. It just merely clarifies them and provides a little better definition as to what those requirements are in fact. Next slide, please. This slide just goes into more detail, reiterating what I've already said. Next slide, please. So how's that for speeding up, Michelle?
Thanks, Phil.
Making up for all the time that Ken took.
Yeah, indeed. So let's start our Q&A session. This is going to cover all of Subpart B. Our first question is whether or not a safety approval can be obtained for a software application.
The answer is yes.
Yeah, that one's an easy one. Absolutely. Today, it is a standard practice to tailor RCC 319 with applicable federal range and the FAA when seeking to qualify and certify a flight safety system. Will a tailored RCC 319 be an acceptable means of compliance, or must we now comply with an untailored RCC 319? And I can take that question.
I'll let you take it.
So any accepted means of compliance, you have to meet every part of it. If you want to tailor something, you have to submit it to the FAA as a unique means of compliance. So the answer to the question, no, you do not have to meet the untailored. We expect, for example, RCC 319 to be one of those means of compliances that will be tailored and will be submitted to the FAA as a unique means of compliance.
And just as today, I might add that we work very closely with our partners in DoD and NASA relative to tailoring flight safety system requirements, and that would continue under the Part 450 regulation.
Okay, here's a question on the policy review. Does the policy review provide information required to meet the space system registration requirements per the Outer Space Treaty?
No, not directly. That's a separate requirement under the Part 450 requirements to provide information that's necessary to meet our obligations. And that'll be discussed, I think, on day 3.
Right, yep, Subpart D. Here's a question about the encryption. Is the encryption question like a yes or no question, or what type of more data do you need on the encryption requirement?
I think that I don't remember exactly what's in the exact language, but we expect a description of what encryption is used, not a yes or no.
Yeah, and in the preamble, it says that the encryption information you provide in your application allows the DoD to assess the impacts on national security due to the potential cyber intrusion or loss of vehicle control. So there is a description. The next question is, do the requirements in 450.43I apply to payloads covered under 450.43B? Where the review is requested or required, will compliance with something akin to the data protection plan that NOAA requires for remote sensing licenses?
I'd have to look at that one, Michelle.
So I think the FAA needs the information on all payloads. Hold on one second. Where did my question go? Okay, there it is. The FAA needs, oh, wait a minute, it disappeared again. Okay, there it is. So the FAA needs information on all the payloads, including those owned and operated by the government. We need the information to determine that the payload is indeed owned and operated by the government, and that the safety implications of its launch or reentry. If it is a U.S. government owned or operated payload, we do not look to the national security or foreign policy implications of the payload because we accept the other agency's determination in that regard.
Right. And I think we said that when we were going through the charts.
Right. Okay, so the next question is, why do you not give payload operators the flexibility to initiate a policy as well as a safety review on their payload?
Because essentially the payload review would encompass the same kinds of issues that policy would, but those are the issues, policy type issues that refer to the payload. So it would be redundant. The policy issues refer to the launch or the reentry. The payload review requirements refer to the payload, and the policy considerations relative to a payload are incorporated within the payload review.
Okay. We have a couple more questions. If a launch operator contracts with one of the FAA approved launch ranges for launch, and their range safety organization provides their standard processes for ground and flight safety to perform the required safety analysis, the 5 means of compliance, does their process suffice as a means of compliance to the FAA with no additional information required? And I think the answer to that is we have in 450, was it 40? 45B, the services from a federal range. And the FAA will accept any safety-related range services as long as the administrator determines that it satisfies Part 450.
Yes, without any additional information from the launch operator, other than verification that they're availing themselves of that service.
Right, and that's also true. I know some of our previous operators have had the range do some services for them even when they weren't launching on the federal range. So that's another point. When will the advisory circular be released on pre-application consultation? So if you go, I believe that may not be in the means of compliance table. It may or may not be, but I think it is in the spring. We can get a good follow-up question on that. But the payload review process will be part of the pre-application consultation AC. And Phil, does the FAA intend to issue feedback or approval if the interagency review is positive?
If it's done separate from the license application, the answer is yes. We have received very few, maybe one or two policy reviews that were requested independently from a license application. As I've said during the presentation, that we've received numerous payload reviews independent of a license application. But the answer in both cases is yes. We notify the applicant of a favorable determination or of a non-favorable determination.
Okay, so we're a little bit over time, but one last question we'll answer quickly. If an operator wants to modify to add an additional launch with a different payload, what is required for them to submit? Can an applicant request approval to launch a class of payloads?
The answer is yes. They can request a class of payloads, and then we have a requirement that 60 days prior to the launch, that's the current requirement, or at some other time that the FAA agrees to, the specific payload and payload information needs to be provided. But we do authorize generic types of payloads. But then the specific payload information is required at a later time.
Great. Okay, well, we were a couple minutes over, so we want to give folks a time to stretch their legs. We will come back at 1:51 Eastern time. And at that point in time, we're going to dig into our favorite part, Subpart C, the safety requirements. All right, we'll see you in a few minutes. Okay, I'd like to welcome everybody back. Right now, we're going to go into 450 Subpart C, our safety requirements. And with that, I'd like to introduce the one and only Dr. Paul Wild.
Good afternoon, everybody. Can you hear me? Hello?
Yeah, we can hear you 5 by 5.
Okay, terrific. So good afternoon, everybody. My name is Paul Wild. It's a real honor for me to present the heart of the rule. We intentionally labeled this one 101 because it's so fundamental. And as a Stephen Covey fan, I want to begin with the end in mind. So the first item on the agenda is the purpose. What is the purpose of this section 101? After that, we're going to go into the different types of risks and the relationships between those risks, and then an introduction to the rationale for the criteria itself. As you can see, there's a number of new features that have been introduced, and we'll cover each one of those as well. Next slide, please. So the fundamental purpose of this safety criteria in 450-101 is to define how safe is safe enough. So the criteria include individual and collective risk limits that separately apply to launch and reentry. And the most fundamental of those is the expected casualty, the collective risk requirement. And we'll explain it in more detail, but basically the fundamental requirement is to have no more than 1 × 10⁻⁴ expected casualties. That would be during a launch or during the reentry. And then the individual risk requirement, no more than 1 in a million or 1 × 10⁻⁶ probability of casualty. And we'll explain the difference between those types of risks shortly. But the purpose of the safety criteria in 101 goes beyond just demonstrating compliance with these fundamental criteria. They also provide a basis for well-informed decisions and identifying the sources of public risks and those uncertainties, as well as, most importantly, the potential mitigations. In addition, the safety requirements in 450-101 and the flight safety analysis to demonstrate compliance with those helps inform the FAA's maximum probable loss determination that sets how much insurance an operator needs to protect third parties as well as U.S. government property. So I want everybody to realize that, you know, we've written waivers in the past. All the past waivers are consistent with the criteria that's now in 450-101. Next slide, please. So we're going to spend a little time on this slide and just talk about risk as a concept. Risk as a concept, the mathematical formulation was first done by Blaise Pascal hundreds of years ago. And it's important to understand the different elements of risk. So there's three key elements. The probability of a dangerous event. So the probability that a rocket would crash. The second key element is the size of the danger area. It would be the size of an area that would be destroyed if the rocket were to crash. We also call that the casualty area. The third key element is the public exposure, because you can have a rocket crash and have it destroy an area, but if there's no people there, there was no risk to the public. So public exposure is a third key element, which is often part of the mitigations controlling the public exposure, as we'll see. So risk is formally computed as the product of probability and consequence. So when you take that casualty area and combine it with the public exposure, that's the consequence. And any risk controls or mitigations must address at least one of these key safety elements. So for example, reduce the probability of the event by doing a really good job on your system safety and designing your rocket well so it doesn't crash. You can reduce the danger area, typically by making sure that you don't have any intact impacts, especially with propellant on board, which tends to make a big explosion. Or of course, controlling public exposure by evacuating people. So September 11th made it pretty painfully obvious to everybody that an airplane crash can have horrific consequences. Well, if a rocket impacts the ground intact with tons of propellant, it can make an even larger explosion. The space shuttle is a good example. The space shuttle could have produced an explosion hundreds of times bigger than the bomb that destroyed the Murrah building in Oklahoma City and killed 168 people. It could be more devastating than any plane crash. On the other hand, the Columbia accident didn't hurt anybody in the public. And part of the reason was that the debris hit an area that was relatively sparsely populated. But also, when the orbiter broke up, the average piece that was recovered on the ground weighed about 1 pound. And so sheltering provided by people's roof out in East Texas was sufficient to protect them. So the casualty area can be highly variable depending on many things. What a lot of people don't understand is, of course, the probability. The probability is purposefully marked in gray because it tends to be a gray area. I think it's relatively simple for people to understand, what is probability, and dice is our best example. The probability of rolling a 6 is 1 out of 6. But the probability of a rocket crash is much more difficult. We'll talk about how that gets demonstrated. But it's important to understand the relative probability of a crash of a rocket compared to a traditional aircraft. So if you take some of our best rockets, for example, this space shuttle, the space shuttle experienced 2 fatal accidents and 135 missions. If commercial transport aircraft crashed at the same rate as the space shuttle, we'd expect 150,000 airline accidents per year in the US alone, which translates to over 400 crashes a day. So the probability of a rocket crashing, in particular a large orbital rocket, is orders of magnitude higher than the probability of a commercial transport crash. So the Columbia Accident Investigation Board repeatedly warned that rockets and reentry vehicles should not be treated like routine operations. And they included the mischaracterization of the shuttle as operational among the organizational causes of the accident. Quote, "The organizational causes of this accident are rooted in the space shuttle program's history and culture, including the mischaracterization of the shuttle as operational rather than developmental." That's from page 9 of volume 1 of the Columbia Accident Investigation Board report. So it's very important to keep in mind the relative probability of the crashes of rockets and aircraft vastly different. The fact is that physical laws make space launch, particularly reaching orbit, very difficult. And even our best orbital rockets ever built on average have a failure rate of about 1 out of 100 per flight. The next slide, please. So there's 2 fundamental types of risks that AST regulates, and I mentioned these. We have individual risks and collective risks. We regulate the risk of a casualty. A casualty is defined as serious injury or death. And then for purposes of the flight safety analysis, serious injury is defined by the abbreviated injury scale, level 3 or more. So your individual risk is basically the chance of a specified individual getting hurt or killed. And that's a probability. Collective risk, on the other hand, is not a probability. It accounts for the chance that some member of a group of people becomes a casualty. So a good example, it's a bit gruesome, but to try and understand the difference between individual risk and collective risk, imagine that you have 10 stadiums as big as the Rose Bowl, each hold 100,000 people. And in this hypothetical scenario, there's a gunman who's got a single shot rifle, and he plans to attack one of these 10 stadiums that each have 100,000 people. So if you're in one of those stadiums, then your individual risk is 1 in a million. And whereas you might not be terribly worried about that, the government is very worried and wants to stop this attack because the expected outcome is 1 casualty. Now, if the gunman had a multiple shot clip, then the expected number of casualties would exceed 1. And so now you can see that expected casualties are not a probability because probabilities can never exceed 1. So in this example, you also see the relationship between individual risk and collective risk, which is if all individuals are equally exposed, their individual risk is the same. In this case, 1 in a million for our single shot rifle. Then the collective risk is the sum of all those individual risks. So summing up to 1 in the case of the single shot. So for the launch and reentry, we have the separate criteria, the maximum individual risk of 1 in a million, and the maximum collective risk of 1 times 10 to the minus 4. So basically our flight risks are managed so that if we had 10,000 missions, we'd produce no more than 1 casualty on average after those 10,000 missions. That's if each one of those missions had an expected casualties of 1 times 10 to the minus 4. So to think of it more realistically, if we had 100 missions a year for 100 years after that time period, if we did our calculations correctly, then we would have, we would expect 1 casualty after those 100 years. Okay, next slide, please. So I wanted to provide an overview of the underlying rationale for our individual and collective risk criteria. So the most fundamental elements of the risk criteria that we just covered, the individual risk and expected casualty, in 450 are unchanged. Therefore, the regulatory rationale was provided during the promulgation of our 2016 final rule that updated AST's basic risk criteria. So you won't find much of this in 450 because we didn't really change anything. But this slide addresses the underlying technical rationale, which is illustrated as a pyramid. So starting at the foundation, we have some legal principles. Risks should be reasonable. We should have a rational connection between the facts and the criteria. We want our decision makers to make informed decisions. And then we get into some Latin words, de minimis, meaning trivial, a trivial risk, or a de manifestis risk, meaning an obvious risk. So what's interesting about those legal principles is when you ask, well, what is reasonable? It's really in the eye of the beholder. There's no hard, fast definition. What's a reasonable risk? And so the next layer up, we look at some policy goals. We wanted our criteria to be consistent with background risks, meaning risks that people experience day to day. For example, if you're a pedestrian in the United States, there's some risks that you could get hit by an automobile. That's a direct analogy to our third-party risks in the rocket business, meaning people on the ground have nothing to do with the flight of the rocket, just like me walking down the street doesn't have anything to do with the automobile transportation. We look at the risks in other industries. We've always wanted to have common standards. It's very important to have common standards with our other partner agencies that regulate launch and reentry risks, such as NASA and the Space Force. We want to have limits that are consistent for different types of launch and reentry vehicles, and we've achieved that. Now, when you look at the risks allowed in other industries, formally allowed in other industries, such as nuclear power or aviation or chemical power plants. The Department of Interior regulates dams, okay? So when they fail, they can cause floods and people get hurt. I mentioned cars. What you'll see is there's an enormous spectrum of what's deemed acceptable based on some of these public concern factors. How familiar are people with the cause and effect? How horrific are the consequences? So you can imagine, on the one hand, nuclear power has incredibly stringent safety criteria compared to something like the regulation of dams, because floods have been happening since the dawn of civilization. People have a feeling like they understand the cause and effect. They may feel like they have a sense of personal control. I can go drive up to a high point or something. And so you can see that these concern factors are quite different for something like dams compared to nuclear power. And then there's another important factor about the equity between the perceived risks and benefits. So looking at all that, where we came down was very close to the risks imposed by aviation. And we'll see that later on, that we've used a guiding principle that the risks from the overflight of launch and reentry vehicles should be no more dangerous than those imposed by the overflight of conventional aircraft. And then the last element up there is the fact that we intend to balance the factors involved. I mean, if our only objective was safety, of course, we could simply say no to every launch license application. We know there's risk involved, but we want to balance the needs for space transportation, taking into account the fact that the Congress, there's two key congressional findings that are quite important here. Space transportation is inherently risky. That's a direct quote from the statute. And at the same time, space transportation is vital to the nation's economic well-being and national security. So we know it's risky, but it's extremely important, and we want to strike the proper balance so that we can, have safe and successful launches and not just say no to everybody and have perfect safety. Another congressional finding was that the United States that we should regulate commercial space transportation safety only to the extent necessary. So we've attempted to impose the minimum level of requirements to ensure public safety. Okay, so I mentioned that AST's collective risk criteria is on par with the overflight of conventional aircraft, and the risk from a commercial transport flight is basically 1 in a million expected casualties. That's not the result of any amazingly sophisticated calculations, but if you just take the number of people hurt on the ground over the last 30 years from commercial aircraft transportation, and then you divide by the total number of flights, you get a number that's pretty close to 1 in a million. So that gives you a relative sense of the risks and the underlying rationale. There's more information available as cited down below. Next slide, please. Okay, so this slide shows the major elements. They're in section 101, each of which is described in some detail in the upcoming slides. So 101, of course, sets the public and property safety criteria that are fundamental. We have the separate individual and collective risk criteria for people that meet definitions of neighboring operations personnel. We have a separate slide on that. We've added a risk criteria for the protection of critical assets that are essential to the national interest of the United States, including a more stringent requirement for the protection of critical payloads. The FAA received extensive comments and made significant changes to allow for additional flexibility in measuring and mitigating high consequence events. So we'll go through that. We have several slides on that subject. 450-101F requires public notification of any planned impacts capable of causing a casualty. And so regardless of the risk that's associated, we believe the rule requires that if you intentionally create a hazard, you should inform people that there is a hazard in that region. And we'll see more detail on that in paragraph F. And lastly, 101 includes some qualitative standards on the requirements to demonstrate that the analysis methods are valid, and we'll see those. Okay, next slide, please. So this slide shows the fundamental collective risk criteria in terms of expected casualties for launch. And you'll notice that these criteria must be met before an operator may initiate flight of a launch or reentry vehicle. in this case, launch vehicle. It's similar on the subsequent slides about reentry. Therefore, the risk analyses must demonstrate compliance given the conditions at the time the operation is initiated. So an example of that would be the weather conditions. You know, you may have a risk analysis that shows, you know, given the average monthly weather conditions, you could meet the risk criteria, but the question is, do you meet the risk criteria given the weather conditions that you have on that day? So that's fundamental. The other important thing to notice about this is that here we're essentially setting the scope of the flight risk criteria. So it applies from liftoff through orbital insertion for launch. And we did define formally in 401.7 that an orbital insertion means the point at which the vehicle achieves a minimum 70 nautical mile perigee, based on a computation that accounts for drag. So we have a formal definition of orbital insertion. The 101 criteria applies collective and individual risk to people on waterborne vessels. So if you read the statement, you know, in A1 little I, you'll see it says the risk to all members, excluding persons and aircraft and neighboring operations personnel, must not exceed the 1 times 10 to the minus 4 expected casualties. So implicitly there, the collective risk criteria does apply to people in waterborne vessels. That's the most general term that we use for ships and boats of any size. So this enables risk management techniques that previously required a waiver under 417. The last point I wanted to make on that slide is that this fundamental criteria applies to all members of the public, whether they're located on controlled or uncontrolled areas, meaning where the launch site operator can limit the access to the public. That's a controlled area. But all members of the public, regardless of their location, are protected by the risk criteria. So we have a separate slide that talks about uncontrolled areas and goes into more detail about neighboring operations personnel. Next slide, please. Okay, so this slide shows the fundamental individual risk criteria in terms of probability of casualty for launch. And you'll see that it accounts for the aggregated risk posed by our classic hazards of impacting debris, whether it's inert or explosive, a toxic release, or a far field blast overpressure. If there were some other hazard, we would consider that on a case-by-case basis. So an other hazard could include radionuclides. If the payload, for example, uses nuclear materials as a power source, that would be an other hazard that would be handled on a case-by-case basis. As I mentioned, the individual risk cannot exceed 1 in a million probability of casualty unless that individual qualifies as a neighboring operations personnel. And if they are, neighboring operations personnel are allowed 10 times higher risk. So 1 times 10 minus 5, or 1 out of 100,000 probability of casualty. So this individual risk requirement to ensure that no person exceeds the 1 in a million really drives some of their surveillance requirements. So an operator must ensure, for example, via surveillance, that no member of the public, whether they're on land, sea, or air, would be exposed to that higher risk, higher than 1 in a million probability of casualty at the time that the operation is initiated. So the 1 in a million probability of casualty is embraced internationally. It's broadly acceptable on an annual basis for individual risks that are involuntarily imposed. The neighboring operations personnel, we consider they're voluntarily in accepting a higher risk, that they're informed about those risks. But this 1 in a million is really very, very safe. Nobody should be afraid, in my opinion, to go to a rocket launch and get as close as the law allows. Because if you were, in fact, at the 1 in a million probability of casualty level, imagine a certain set distance back from rocket launch, and if that rocket launch occurred daily since before Rome was founded, so from 720 BC to today, after that, that's about 1 million days. And so you'd be statistically expected to be a casualty. So it gives you an idea that 1 in a million really is very, very safe. Next slide, please. So this slide talks about the new individual and collective risk criteria for neighboring operations personnel. So 450 adopted these separate criteria for neighboring operations personnel, which are considered a subset of the public, and they have to meet this definition. The definition's there. I'm not going to read it. It's very similar to the definition that are used today by NASA and the United States Space Force. So neighboring operations personnel are allowed 10 times higher individual risk, but also we've established a collective risk limit of 2 times 10 to the minus 4. So a separate risk budget in terms of collective risks just for neighboring operations personnel. That's 2 times higher than the other parts of the public. As far as the aircraft protection, 450 keeps our current aircraft protection criteria. Hazard areas must be established such that no aircraft is exposed to greater than 1 in a million probability of impact with debris capable of causing a casualty. So because there was an ARC convened on aircraft protection during launch and reentry while the 450 rulemaking was ongoing, 450 did not contemplate any changes to AST's aircraft protection criteria, but we deferred that to a subsequent rulemaking. Next slide, please. So this slide focuses, and the next slide as well, on the new critical asset protection criteria for launch. So in addition to our explicit requirements to protect people, in the past, we used to basically assume that by protecting the people, we had an adequate level of protection for property. But that's not true anymore. In particular, we now have areas of a launch area that would be evacuated of all people, and they have some exquisite, very expensive, very important assets that are critical, that meet this definition of a critical asset. So I'm not going to read the definition. You can read the definition, but 450 embraces this new requirement that's consistent with our current NASA and United States Space Force requirements. I can cite those specifically if you want. So this does not represent a change in current practice for most launches that, of course, occur from federal ranges where these critical assets generally are located. So the United States government is going to determine if a launch would meet this criteria. We got a lot of comments to the NPRM saying, wow, that's going to be difficult for us to know, what are critical assets, what's their vulnerability. And so we took that seriously and decided, okay, the United States government's going to perform that analysis on behalf of the operator. But the operator must receive confirmation that their operation is in compliance prior to initiating the launch or reentry. That requirement's explicitly in 450.168A5. Next slide, please. So this slide shows elements of the new critical asset protection criteria for launch that were updated based on our extensive coordination with our U.S. government partners in the Department of Defense and NASA. So you'll see that the United States government is going to determine what constitutes a critical asset. And we're going to do that in coordination with our partners. And the FAA reserves the right to apply a more stringent criteria if necessary to protect the national interests of the United States. So it's important to understand those key definitions. But in the end, the government's going to make a determination based on those definitions. And in some cases, for example, if we were facing a wartime situation and there was a critical payload, let's say, that was necessary for that warfighting operation, we may find it necessary to impose an even more stringent requirement. Now, of course, we don't anticipate that, but that's there as an option for those extreme circumstances. The critical asset evaluations are often completed using preliminary data. So during the pre-application or the license evaluation, in many cases, the issue can be resolved at that point. However, there could be a circumstance where prevailing weather conditions are important to meet the critical asset risk criteria. And in that case, an assessment would be performed either close to or on the day of the launch. That last requirement there in for little v is important. Basically, what it's saying is that the criteria doesn't apply to critical asset, that the critical asset criteria doesn't apply to properties or facilities, infrastructure that are supporting the launch that would be within the public transport or public area distance from our quantity distance requirements, which we have cited there in 420 Appendix E. So essentially, if they're part of the immediate launch complex and they're used by the operator for a given license operation, those assets are exempt from the critical asset protection requirements. Okay, next slide, please. Okay, so here we see the fundamental criteria applied to reentry. When you read through this, you'll see that the reentry criteria has a different scope, of course. It can't be liftoff to orbital insertion, but instead applies from when an operator initiates the deorbit of the vehicle, from the final health check prior to initiating the deorbit through the final impact or landing. So of course, the scope of the risk is different than launch. However, all the criteria are identical. So we have the same individual risk criteria of 1 in a million, probability of casualty, collective risk criteria of 1 times 10 to the minus 4 expected casualties, neighboring operations, they're all exactly the same, including critical assets and protection of aircraft. Next slide, please. Okay, so now we're going to get into the high consequence events. There's several slides on this subject. The first important thing is to understand some key definitions. So 450 did not formally define high consequence event. However, the preamble did state what you see there. And notice that it opens up with high consequence events include incidents that could involve multiple casualties. And that's very important because when we are talking about risk acceptability, the fact is that public perception of incidents that involve multiple casualties, especially very large numbers of casualties, is quite different than single casualty events. And so as a practical matter, in the advisory circular on this subject, which we've published in draft 450-101-1, we've for the purposes of the advisory circular focused high consequence event protection on events that could cause multiple casualties. So another important aspect is to recognize that this high consequence event protection applies in uncontrolled areas. Okay, so for each phase of flight. So an uncontrolled area is an area of land that's not controlled by a launch or reentry operator, a launch or reentry site operator, an adjacent site operator, or an other entity by agreement. So this provision is consistent with current practice. For example, our friends in the United States Space Force at Cape Canaveral Air Force Station and Vandenberg Air Force Base. This enables the launch site authority to decide what's an optimal balance between the chance of casualties, the chance of a casualty, and the chance of multiple casualties. So that can be a very difficult balance to strike. And so if you imagine you're the launch site operator, you have a choice, okay? There's, let's say 1,000 people that want to watch the launch, okay? So you could put all 1,000 people right up on the 1 × 10⁻⁶ individual risk. Actually, you couldn't, that would exceed the criteria. Scratch that, 100 people. So if you had 100 people right on the 1 × 10⁻⁶ probability of casualty level, okay, you're reducing the chance that the rocket hits that one area where you have 100 people. But if it does hit that area, you could end up with 100 casualties in a single event. So is that better than distributing these 100 people, equally spaced, but far enough away that no single event can cause multiple casualties? So we leave that decision to the launch site operator to strike that optimal balance. Okay, the other point is that in this requirement, we talk about each phase of flight and then looking at the expected casualties in a significant period of flight. In the NPRM, we specified a 1 second period of flight. That is probably a good period, but we backed off to just a significant period of flight, and in the advisory circular stated that a period of flight between 2 milestones in the vehicle flight sequence is not necessarily a set period of time. Okay, so there's many layers to this, but before we leave this slide, I wanted to point out that again, the people that are in the controlled area must be accounted for to demonstrate compliance with the fundamental risk criteria that we just saw in 101A and B, are individual and collective risks. So those folks are still protected to a very high level. Next slide, please. Okay, so here we see the high consequence protection options. So this slide shows the actual regulation text in 450-101C. and it explicitly allows 3 options to demonstrate adequate protection for high consequence events. So in option 1, you could simply choose to use flight abort and meet the flight safety limits criteria in 450-108. This might be a very reasonable choice. If you look at some of the past work, which we did summarize, and we do plan to put a more complete summary report on the docket about past launches, the analysis that we've done specifically showed that 10 out of 10 launch vehicles launched from within the continental United States that we looked at, these are past real launches, would need a highly reliable flight safety system based on our requirements in 450.108b. And so an applicant can simply choose to skip the conditional expected casualty analysis entirely, okay, and choose to comply with the requirements in 450.145 for a highly reliable flight safety system. So it's possible to avoid doing a conditional expected casualty analysis at all. Now, the conditional expected casualty analysis is really built on top of and implicitly inside the expected casualty analysis. It's simply assuming a probability of 1 for some events. You know, some failure mode happens in a particular phase of flight. What's the consequence of that? What are the conditional expected casualties? So the second option, go ahead and perform the analysis, looking at all the reasonably foreseeable failure modes in any significant period of flight. And if you can demonstrate that no matter what happens, no matter what failure mode happens, no matter what period of flight, if there's no more than 1 times 10 to the minus 3 conditional expected casualties, you're done. You don't need a flight safety system at all. And so a good way to think of this would have been the Columbia accident itself. So if you read the Columbia Accident Investigation Board report, there's a section that talks about public risks. And the board commissioned a study, you know, given that accident occurred, when it occurred, where it occurred, what was the probability that somebody on the ground would be hurt? What were the conditional expected casualties? And what we came up with was it was between 10% and 30%. So 0.1 to 0.3, that uncertainty was really driven by the fact that the launch, or the reentry in this case, the breakup occurred at 8 in the morning, and the uncertainty in how many people, the percentage of people that were outside, because as I mentioned, the orbiter broke up into pieces that on average were about 1 pound in mass, and people indoors would have been protected. So, so in that case, you could see that the orbiter would have failed and would have needed some sort of flight safety system. What fewer people understand is if the Columbia would have gone 1 more revolution around the Earth before making the landing, the same point in flight would have occurred such that the breakup would have tragically spread debris over Houston, my old hometown. And there, the conditional expected casualties were whole numbers. We would have expected 2 or 3 people to be seriously injured or killed in that event. So, so the rule does allow a option to have no flight safety system, and there it is. It's less than 1 times 10 to the minus 3 conditional expected casualties. So there's a third option, which I know there's been there's a lot of questions about, and we're going to answer some of these questions in the upcoming slides. But it's possible to establish that your vehicle has sufficient demonstrated reliability okay, that demonstrated reliability level is based on the conditional expected casualties. So you might have a vehicle that has conditional expected casualties of, let's say, 0.01 or 0.1 or even 1, okay? If you have sufficient reliability, if you have sufficient reliability, then you've demonstrated adequate protection against high consequence events. So our standard has been that the demonstrated reliability needs to be equivalent to aircraft type with a standard airworthiness certificate. We'll see a little bit more about how that works on the next slide. Okay, so this slide shows figure 3 from our AC 450 101-1. It's a plot showing the acceptable probability of failure, okay? 1 minus the probability of failure is the reliability. And how that acceptable probability of failure depends on the maximum conditional expected fatalities. So this plot is part of a quantified example means of compliance that's based on the concept that vehicles can have sufficient reliability to forego any flight safety system, any flight abort capability, based on the potential for a high consequence event. So as explained in the preamble to the final rule, the FAA will use demonstrated reliability and average ground consequences from fatal accidents involving U.S. civil aviation aircraft with standard airworthiness certificates to establish what constitutes sufficient demonstrated reliability to protect against high consequence events. So clearly, conventional aircraft such as general aviation aircraft and commercial transports with standard airworthiness certificates are reliable enough that the FAA does not require a flight safety system that's traditional on most launch vehicles. So the 2 points that define the left and the right side of this plot are based on empirical data on the conditional expected fatalities from fatal accidents from aircraft. So specifically, a carrier vehicle with a conditional expected casualties near 1 times 10 to the minus 2 on the left, that's on par with a subset of fixed wing general aviation aircraft, okay? So empirically, again, you just count the number of general aviation flights and the number of people that are seriously injured or killed over the last 30 years, and you'll see that the conditional expected fatalities from a general aviation crash involving this type of aircraft, fixed wing, after on average 100 fatal accidents, we have 1 person on the ground that's killed. But fatal accidents, of course, typically involve the person on board the aircraft, unfortunately perishing. Now, commercial transport aircraft fail, of course, much less frequently. Okay, so their probability of failure is way down, below 1 in a million. But when they do crash, on average, again, you get 1 person on the ground seriously injured or killed. So typically it happens, you get a bunch of zeros in terms of people hurt, killed on the ground, and then an accident that produces a handful. We have seen some accidents that have produced dozens, and we're not counting malicious events like September 11th. So what we're doing is we're saying that if your vehicle, okay, such as the Pegasus that used in L1011, has this type of demonstrated reliability, sure enough, you can exceed the conditional expected casualty limits and still not need a flight safety system. So This is explained in section 13.3 of the advisory circular. And there's also a simple and conservative integer method down there to compute the CEC based on the approximate maximum population density that your vehicle might overfly, etc. So one point I wanted to make is that the level of demonstrated reliability in this figure requires extensive flight history. So for example, if you were to use a binomial approach, and many of you know that the binomial approach has been the backbone of the approach that we've used for launch vehicles. But if you wanted to demonstrate the 8 times 10 to the minus 6 failure rate that's on the left side, basically, at a 50% confidence level, you'd need 87,000 flights without a failure to demonstrate that level of reliability. So quite obviously, no rocket has ever really approached anything like this itself. However, we have launch systems that involve carrier aircraft, carrier vehicles, and rockets such as the Pegasus that could demonstrate compliance with this approach. The L-1011, as I recall, had millions of flights without anyone on the ground being hurt. I think there was one person hurt on the ground after some 4 million flights. So, so I encourage you to read the advisory circular and provide us comments. But hopefully this helps you understand what we mean by the demonstrated reliability being commensurate with the conditional expected casualties or fatalities. Okay, next slide, please. So Michelle already briefed this slide. It just, I think, kind of puts a lot of things together. So we talked about whether or not the flight safety system is required, and we have these threshold levels below 1 times 10 to the minus 3. The answer is no. In between 10 to the minus 3 and 10 to the minus 2, you can have, you must have a flight safety system, but it needs only comply with our section 143 requirements, whereas above that, you need to have the highly reliable flight safety system with 3 nines at 95%. Now, the other thing that the conditional expected casualties does for us is help inform decisions about when the flight safety system needs to be activated. And we'll have more extensive presentation on that next, I think tomorrow. And I'll talk a little bit more about that on the next slide. Next slide, please. Okay, so this is a sample flow chart of a high consequence event protection analysis or thought process. And if you start on the right-hand side, you'll see that a flight safety system, is generally activated in the context that, number one, the vehicle is no longer performing nominally. Okay, you don't need the flight safety system. The vehicle's performing nominally. Okay, the vehicle is now outside the limits of a useful mission, and continued flight would continue to increase the public risks in uncontrolled areas. So an example of this would be the Challenger. Challenger accident happened January 28th, 1996. That's STS-51L. And so the vehicle exploded, but then the solid rocket boosters continued to fly intact until the flight safety system was activated. So at that moment, when we saw, lo and behold, despite what several experts said could never happen, okay, the solid rocket boosters could never fly stable, okay, but they did. And in that moment, we needed to decide, okay, when are we going to push the button to blow those up? And so The context of a flight safety system activation occurs when you're in a condition already, and hence the logic of using conditional expected casualties to establish when you should activate the flight safety system. So on the left-hand side, you'll see that an operator could still demonstrate compliance to everything, including 108, without computing the CEC. And we'll explain a little bit more about that tomorrow. However, calculating the CEC helps ensure that you as an operator recognize certain system failures may have catastrophic consequences and build in mitigations into the system that account for those failures, such as a flight safety system. Michelle pointed out that we are open to alternative ways to measure high consequence events other than CEC based on 450.37b. So I wanted to just quickly run through the flow chart. If you start at the top, the applicant decides what approach they want to use. They could go to the left and just decide, I'm skipping all the CEC stuff. Based on previous studies, I'm launching from the continental United States. I have an orbital rocket. I'm just going to use a highly reliable flight safety system and demonstrate compliance that way. On the right-hand side, you could say, hey, wait a minute. I'm not a traditional, vertical launched rocket. I've got, a carrier aircraft, and therefore I might not need a flight safety system based on my demonstrated reliability. And then the other in the middle, you go through and you actually do the CEC analysis in a step-by-step way. What I wanted to point out is that typically the failure mode, the random attitude failure mode is the driver for conditional expected casualties, but there may be others. And one of our other ACs does explain sort of a generic list of failure modes. So, once you've decided whether you need a CEC or whether you need a flight safety system, if you do choose to have a flight safety system, then when to activate it does involve protecting against high consequence events as well. Okay, next slide, please. All right, so yeah, I know we're getting close to the allotted time. These last slides won't take very long. So this slide talks about the disposal criteria. So 450 sets a safety criteria for a disposal. And you see the definition of disposal there. The important part, it's a purposeful attempt to return the launch vehicle component, let's say an upper stage. But that's different from a reentry, because a reentry was defined by Congress in the statute, and that involves a purposeful reentry where the vehicle remains substantially intact. Therefore, a disposal is different from a reentry in that the vehicle is not expected to remain substantially intact, and thus it's separate. So 450.101 Delta allows two options to demonstrate the disposal is safe. You could either demonstrate compliance with the risk criteria, the individual and collective risks, or target a broad ocean area. And as explained in the preamble, the FAA considers a broad ocean area as an area 200 nautical miles from land. This last paragraph, not the last one in the whole section, but on this slide, deals with the protection of people and property on orbit, and we have a separate session that will go into that. I'm sure Steph Earl will explain that. Next slide, please. Okay, so here we have our last slide on section 101 that shows the quantitative safety criteria for the notification of planned impacts and a qualitative criteria in paragraph G, golf, used to establish the validity of analysis that's used to demonstrate compliance with 101. So some planned impacts, for example, a sounding rocket where you have extremely large dispersion of one of the upper stages, can be so dispersed that there's no area where an individual would be exposed above the 1 in a million probability of casualty. So even if that's true, when creating that hazard, this requirement says you should notify, you must notify the public of any planned impacts, and the area corresponds to an area where you have 97% confidence of containment. All debris capable of causing a casualty. So we'll probably explain a little bit more about that in the Q&A session. What do we mean? Events capable of causing a casualty. The last paragraph in 101 deals with the validity of analyses. And so you can see the requirement is to use accurate data, scientific principles, and an analysis that's statistically valid. So pretty hard to argue with that, but what does it mean? So on the left-hand side, we put some guidance that accurate data refers to completeness, exactness, and fidelity to the maximum extent practicable. We know what scientific principles are, like Newton's 3 laws, and statistically valid. Of course, you have to get the math right and account for uncertainty. We'll see in 450.115 tomorrow a little bit more about uncertainties. Thank you for your attention. Now it's over to Michelle for Q&A.
Okay. Well, that was a lot to take in. So I'm sure we have a lot of questions coming up. The first question we have are conventional NOTAMs and NOMARs sufficient to comply with 450.101F for planned open ocean impact of expendable stages and payload fairings?
So the answer is that depends on, how did you define how big that NOTMAR area needs to be? But yes, NOTMARs and NOTAMs are a good way to notify the public of an area, but you have to right size that area to demonstrate compliance with the requirements that we went over. And there's a more explicit section 450.133 that talks about the size of the flight hazard areas.
Okay. The risk to all members of the public, excluding persons in aircraft and neighboring operations personnel, is it correct to assume that this includes public in waterborne vessels?
Absolutely. I mentioned that during the presentation. So, we say excluding those other, people in aircraft. It used to say excluding people in aircraft and waterborne vessels. So waterborne vessels, we have opened up to risk management principles, still have to meet the individual risk criteria and the collective risk criteria.
Is there an objective criteria, such as likelihood, that can be used to determine what constitutes a reasonably foreseeable failure?
We do talk about reasonably foreseeable in our advisory circulars. We have not associated a particular probability level with that at this time. If it's happened before, it's reasonably foreseeable. So you can take that one to the bank.
Okay, great. What is sufficient, in quotes, sufficient demonstrated reliability? Is this open for interpretation or intended to be specific, sufficient flight history? Are there guidelines?
Yes, absolutely. So the chart that I briefed that showed figure 3 from the AC 450.101-1, it's identifies the demonstrated level of reliability that we're looking for, at least if you're going to satisfy that requirement using that means of compliance.
Okay, and there's a subpart to this question as well. If the conditional expected casualty results are showing that an operator needs 99.9% reliable FSS per 145, 450-145, by having a higher CEC than allowed per 450-108B, does 450-101C3 mean that 99.9% vehicle reliability must be demonstrated through sufficient test and flight history to satisfy 101C without a highly reliable FSS?
Okay, that was a whopper. The short answer is no, that's not correct. Instead, if you look at that figure 3 and that AC that we showed on the slides, if you had a conditional expected casualties or fatalities near the 0.01, 1 times 10 to the minus 2 threshold, you'd need a much higher reliability than 99%, 99.939s at 95% confidence. It's closer to 8 times 10 to the minus 6.
Would that be helpful to bring up the chart again, or we have a little bit of time, I think, if that would be helpful? Oh, we have some more questions. Okay, let's
Sarah,
see.
could you bring up the chart, the one with the figure?
I think it's chart 135.
Yeah, chart 135. Thank you. There you have it. So
Yeah.
I was referring to this point on the left side, right? 1 times 10 to the minus 2 CEC, or CEF in this case. And you'd need better than 8 times 10 to the minus 6, so more like 7 times 10 to the minus 6 failure probability. So 5 nines.
Okay. Okay, yeah, you can stop sharing. Thank you, Tara. So for any launch, reentry, or disposal, an operator must notify the public of any region of land, sea, or air that contains 97% probability of containment, all debris resulting from normal flight events capable of causing a casualty. So what are events capable of causing a casualty? Does that take into account sheltering or aircraft vulnerability?
Yes, excellent question. So the, capable of causing a casualty means exactly that. In the past, like in 417, we identified some specific thresholds. So for an example, inert debris impacts, a threshold level that's capable of causing a casualty is 11 foot-pounds or 15 joules, of kinetic energy. Now, if there's no people outside, but everybody's in shelters in the area that debris is predicted to fall, then there could be a higher kinetic energy threshold associated with the sheltering that's provided. And a really good source to get threshold information for different types of shelters is the Range Commanders Council standard, RCC 321-20. In the supplement, we work very hard to make that publicly available, and it is now publicly available. Includes many thresholds for different types of structures, includes vulnerability models for aircraft and ships of different types. So there's a wealth of information about how you would establish what's capable of causing a casualty. It's actually very complicated, okay, because human beings are complicated. The way you get hurt can be very complicated. Something can cause blunt trauma, okay, versus a penetration wound versus being crushed. There's different types of injury mechanisms. Then we have overpressure, and overpressure can hurt you in various ways. So those details are publicly available in RCC 321-20.
Okay, we don't have any more questions in the queue. Let's give folks a couple more minutes and see if they have any more incoming questions on 450 Part 101. So we have one question, I think, coming in.
Yeah, I see that there.
So do you know where the probability of the 97% is derived from? Is it something between 2 and 3 sigma?
Yes, basically. So in 417, the requirement was 3 sigma with a specified level because these are bivariate distributions. And what we wanted to do in 450 was be consistent with the latest approaches, and we wanted to balance the size of these warning areas. If they get too big, they become less effective, especially in the case of a no MAR. That if you have a really big area of the ocean that people are supposed to stay out of, our experience shows that they're less likely to go around it. So we're seeking a balance and what's necessary to be effective.
Okay. We have a question about is a flight safety system excluded from the human-tended portions of a vehicle as it is with range requirements?
So I think this question is asking if you have humans on board, are you exempt from the requirement to have a flight abort system? The answer is no. In fact, a pilot could be part of a flight safety system. So we still want these same levels of protection of the public, whether or not there are people on board.
Yeah, I think that's a great point. I know we've talked in a couple places about, flight abort being a very broad and encompassing definition to include more than just thrust termination or flight termination, that it could be a controlled ending to vehicle flight, which could be an RLV abort, carrying humans.
Yeah, absolutely. Or, a thrust termination is a flight safety system, and you could have the capsule then, pop off and perform an abort. So, yeah, some of the real detailed nitty gritty about when the flight safety system would need to be activated, we may ultimately take into consideration what might happen to those people on board, but the fundamental criteria are the same.
Okay. We don't have any more questions right now. If we don't get any more in the next minute or so, we will just break early. Let's see.
I guess this means I didn't have to hurry as much through the slides.
Let's see. Our next program starts at 3:21. So, and that's on System Safety Program. So we will be back at 3:21. Enjoy a stretch break. Thank you, Paul. Thank you, Randy.
Thanks, Michelle.
Okay, welcome back, folks. Next up, we're going to be talking System Safety Program. And I would like to introduce, actually before I introduce Chris, just want to remind everybody that you can enter your Q&As while he's presenting, and that'll give our folks a little bit of time to kind of process those questions and get them to us. And also, just as a reminder for folks who maybe weren't with us this morning, if you go to faa.gov/space and click on the streamlining rule, you'll get to the Part 450 page, which has all of the new regulations. It has a copy of the charts for today, as well as for the next 2 days, and some of the other goodies like the pre-application consultation templates, RACs, means of compliance table, and all those sorts of things. With that, I want to go ahead and kick off System Safety Program and hand it over to Mr. Christopher Vance.
Good afternoon. Thank you, Michelle. So 450.103 System Safety Program. A system safety program must be implemented and documented throughout the life cycle of a launch or reentry system. Due to the complexity and variety of vehicle concepts and operations, a system safety program is necessary to ensure that an operator considers and addresses all risks to public safety, which include both design and operational changes to the system. AC 450.103-1, planned for Q1 2021, will provide compliance guidance. Next slide. Shown here is a depiction of a generic launch or reentry system lifecycle. Note that public safety hazards associated with the systems and operations of a launch or reentry system are generally reliant on sound design, manufacturing, and operations processes and procedures that span the life cycle. Next slide. 450.103A, Safety Organization. An operator must maintain a safety organization that has clearly defined lines of communication and approval authority for all public safety decisions. At a minimum, the following positions must be included. A1, Mission Director. For each launch or reentry, an operator must designate a position responsible for the safe conduct of all licensed activities and authorized to provide final approval to proceed. A2, Safety Official. For each launch or reentry, an operator must designate a position with direct access to the mission director who is I, responsible for communicating potential safety and noncompliance issues to the mission director, and I, authorized to examine all aspects of the operator's ground and flight safety operations and to independently monitor compliance with the operator's safety policies, safety procedures, and licensing requirements. A3, the mission director must ensure that all of the safety officials' concerns are addressed. A safety official must be named and in place prior to the initiation of any licensed activity, and an operator may use the same safety official for multiple launch or reentry sites. In instances where a single individual is designated to serve as a safety official for multiple sites, when launch or reentry activities occur close in time to each other, an operator may choose to have multiple safety officials. Next slide. 450.103B, Hazard Management. FSA, Flight Safety Analysis, was added to the System Safety Program because demonstrating compliance with 450.101 requires the use of accurate data. B1, an operator must implement methods to assess the system to assure the validity of the determined hazard control strategy and any flight hazard analysis or flight safety analysis throughout the life cycle of the launch or reentry system. Assessment methods for managing hazards include documenting the system safety approach, analyzing systems and operations to identify and document hazards, assessing and documenting initial risk, identifying and documenting risk mitigation measures, assessing and documenting residual risk, documenting verification and validation of risk reduction, accepting risk and documenting acceptance rationale, and managing lifecycle risk. B2, an operator must implement methods for communicating and implementing any updates throughout the organization. Primarily, this is accomplished by the establishment of a safety organization. B3, additionally, an operator required to conduct a flight hazard analysis must implement a process for tracking hazards, risk, mitigation measures, and verification activities. 450.103C, Configuration Control and Management. C1, Employ a process that tracks configurations of all safety critical systems and documentation related to the operation. 2, C2, ensure the use of correct and appropriate versions of systems and documentation of those tracked in C1. And C3, document the configurations and versions identified in C2 for each license activity. Next slide. 450.103D, post-flight data review. Employ a process for evaluating post-flight data in order to D1, ensure consistency between the assumptions used for the hazard control strategy determination, any flight hazard analysis or flight safety analysis, and associated mitigation and hazard control measures. D2, resolve any inconsistencies of D1 prior to the next flight. D3, identify any anomaly that may impact any flight hazard analysis, flight safety analysis, or safety critical system, or is otherwise material to public safety. And D3, address any anomaly identified in D3 prior to the next flight as necessary to ensure public safety, including updates to any flight hazard analysis, flight safety analysis, or safety critical system. Operator review of post-flight data provides valuable safety information on future operations. Inconsistencies that need to be resolved are only those that affect safety analyses and associated mitigation and hazard control measures. Anomalies that need to be addressed are only those that may impact any flight hazard analysis, flight safety analysis, or safety critical system, or are otherwise material to public health and safety and the safety of property. 450.103E, application requirements. An applicant must submit 1, a description of the applicant's safety organization as required by paragraph A, identifying the applicant's lines of communication and approval authority, both internally and externally, for all public safety decisions and the provision of public safety services. And 2, a summary of the processes and products identified in the system safety program requirements of paragraphs B, C, and D. Next slide.
Okay. So we've got a couple questions queued up. The first is, use of the word track through the requirements document is vague. Is there an exact action that is required? Should it be documented, traceable, or rev controlled, for example?
So that specific word is used under configuration management and control. And configuration management and control actually utilizes all 3 of those processes that were used as an example. And is a pretty standard process across industry for ensuring that the correct revisions of documentation is utilized and baselined for each flight.
Okay, we were waiting for some more questions. Please feel free, enter your questions in the Q&A. Okay, no questions so far. We're waiting. I think we all wish we were in a room together in a workshop so we could see the people who had questions. Or you can just tell by looking at them that they would have questions, but we've got this digital process that we just have to wait a few minutes if it comes through. So be patient if you ask a question. It'll just take a second to get to us.
At least we don't have the poor guy running around with the mic.
I thought there might be more questions on system safety program, but maybe not. Okay, well, I think we should probably go on. Chris, you're actually up for hazard control strategies, and perhaps if there's still some straggler questions on system safety program, we can address those at the next Q&A session. So why don't you take it away for hazard control strategies?
450.107 hazard control strategies. 450.107A general. To meet the safety criteria of 450-101 for the flight or any phase of flight of a launch or reentry vehicle, an operator must use one or more of the hazard control strategies identified in 450.108 through 450.111. Specifically, 108 flight abort, 109 flight hazard analysis, 110 physical containment, and 111 when waiting. Flight hazard analysis is characterized as a hazard control strategy because it lays out a process for deriving hazard controls. AC 450.107-1, planned for Q1 2021, will provide guidance, compliance guidance. 450.107B, hazard control strategy determination. For each phase of flight during a launch or reentry, an operator must use a functional hazard analysis to determine a hazard control strategy or strategies that account for B1, all functional failures that have the capability to create a hazard to the public. B2, safety critical systems. B3, a timeline of all safety critical events. Next slide. 450.107C, flight hazard analysis. An operator must conduct a flight hazard analysis per 450.109 for the flight or phase of flight of a launch or reentry system if the public safety hazards cannot be mitigated adequately using physical containment, when waiting, or flight abort to meet the safety criteria of 450.101. The hazard control strategies that are derived from the flight hazard analysis are inputted to the flight safety analysis to show compliance with safety criteria of 450.101. 450.107D, application requirements. An applicant must submit D1, the results of the hazard control strategy determination, including D1I through III, the identification of all functional failures and all safety critical systems and a timeline of all safety critical events. D2, a description of its hazard control strategy or strategies for each phase of flight. Next slide. These are some guidance on a functional hazard analysis, and these are noted as adapted from MIL Standard 882E. A decomposition of overall system to its next level systems and related subsystems to the major component level. Further decomposition may be necessary if relevant to public safety. Note, the FAA expects the depth of system decomposition to vary depending on the level necessary to adequately discern and mitigate impacts to public safety. B, a functional description of each next level system, subsystem, and component identified to include interfaces between subsystems and components. C, a designation of the implementation method for each function, for example, hardware, software, or other. D, identification of phases of system operation. E, identification of failure modes. Next slide. Continuing, F, assessment of end effect resulting from failure of each function during each phase under each failure mode, excluding mitigation. G, assignment of a functional failure identification to allow for traceability. H, assessment of the severity associated with each failure end effect. I, a design scrutiny designation for non-hardware related functional failures based on the severity of the failure end effect and degree of control. J, assessment of whether each failure end effect poses a potential system or mission hazard to the public. Note, grouping of different component or subsystem failures that may lead to the same end effect allows for identification of public safety hazards for the overall system. And K, traceability between each functional failure and associated hazards during each phase of flight to respective hazard control strategies that should mitigate the hazard at the system and mission level. Next slide. This is an example structure of a functional hazard analysis utilizing the bullets A through K that were discussed in the last two slides, being A starting on the left, going to K on the right. Next slide. For guidance on determination and validation of hazard control strategies, 1, define the mission and the system. 2, document a functional hazard analysis. 3, utilize FSA data to better understand the end effect of functional failures prior to mitigation. 5, identify the failure hazard control strategy for each phase of flight. 6, validate the adequacy of the determined hazard control strategy based on documented compliance data from the flight hazard analysis, software safety, safety critical systems design, test, and documentation, flight or wind weighting safety system design, test, and documentation, and the flight safety analysis. Next slide. Guidance on potential determination scenarios. Note, in 450, documenting compliance to 450.143 must be performed for all safety critical systems other than the 450.145 compliant, highly reliable FSS. One potential scenario, flight abort with highly reliable FSFs. For a phase of flight, a flight safety system compliant with 450.145 may be utilized. This mitigation should be validated by FSA data. In such a scenario, the flight abort strategy should adequately mitigate public safety hazards identified by the functional hazard analysis. Another possible scenario, flight hazard analysis with flight abort. For a phase of flight, a flight safety system that does not meet the highly reliable flight safety requirements specified in 450.145 may be utilized. If necessary, a deemed hazard control a combined hazard control strategy of flight abort and flight hazard analysis should identify all necessary mitigations and support documentation of compliance to 450.143 for safety critical systems. These mitigations should be validated by FSA data. In such a scenario, the combined flight abort and flight hazard analysis strategy should adequately mitigate public safety hazards identified by the functional hazard analysis. Another scenario, flight hazard analysis. For a phase of flight, a flight hazard analysis may be utilized. In accordance with 450.107C, a flight hazard analysis must be conducted if the public safety hazards cannot be adequately mitigated using physical containment, wind weighting, or flight abort. The flight hazard analysis strategy should identify all necessary mitigations and support documentation of compliance to 450.143 for safety critical systems. These mitigations should be validated by FSA data. In such a scenario, the flight hazard analysis strategy should adequately mitigate public safety hazards identified by the functional hazard analysis. Next slide. 2 additional scenarios, physical containment. For a phase of flight, the hazard identified by the functional hazard analysis may be assessed as physically contained within the operating area, without further decomposition of system mitigations by the flight hazard analysis. This mission level mitigation should be validated by FSA data and shown to contain hazards. In such a scenario, the physical containment strategy should adequately mitigate all public safety hazards during the specified phases of flight as identified by the functional hazard analysis. Wind weighting. An operator may propose a mission involving an unguided subordinate launch vehicle. For a phase of flight, the operator may utilize a wind weighting safety system compliant to 450.111. This mitigation should be validated by FSA data. In such a scenario, the wind weighting strategy should adequately mitigate public safety hazards identified by the functional hazard analysis. Next slide.
Okay. Well, we have about 2 questions that are queued up for this session. So please keep your questions coming. And after we finish with the System Safety Program Q&A, I would invite, since we're ahead of schedule, to, if you have questions on anything that you heard today, go ahead and type them in. And if our SMEs are still online, we'll do our best to get them on screen and answer those questions too. All right. Well, the first question, Chris, this one's for Randy, actually. For launch from a federal range, does compliance with the range requirements replace the pre-launch ground safety requirements?
So I think we talked about this earlier today. And under 450, it's actually 450.179B. So if you're from Kennedy Space Center, Cape Canaveral Air Force Station, Wallace Flight Facility, or Vandenberg Air Force Base, if you're launching from those sites and you have an agreement with the federal launch range, compliance with their ground safety requirements, if you comply with their ground safety requirements, you do not need to comply with Part 450 ground safety requirements. So that's under Part 450. And we mentioned earlier today also so that we have a ground safety policy out that got put on the website today, and that applies to legacy operators. So under Part 417, 415, 431, and 435, if you're under that kind of license, our ground safety policy covers a very similar approach to ground safety at those federal launch ranges.
Yeah, and I would add that's on our policy guidance website. It's on there now. It's at the bottom of the page, kind of when you're looking at a table. If you look at the dates, you'll see one with November 2020 on it. And it actually, it's a good document. I think the mechanism for that ground safety policy for the legacy operators is actually a waiver. And there's instructions on how to do that in the ground safety policy. And it's actually on schedule to be talked a little bit more about that in the ground safety section, which is, I think, tomorrow or the next day. Next question is, can my company's SMS program find application into Part 450? And Randy, could you take that question?
So I think this kind of question came in the last section on the system safety program. So if a company has an SMS, a safety management system, it might likely meet these requirements. Obviously, the bottom line is if what you're doing in the SMS meets our Part 4 requirements, then fine. It doesn't automatically meet the requirements, but a safety management system is a pretty thorough approach to system safety, and so it would likely meet most of our requirements. But it'd be very much a case-by-case determination.
Yeah, agree. And on that, so the system safety program is specifically the documentation of a system safety program. So if there's more, not necessarily that it all has to be in one document, that the evidence has to be provided to show that you have a documented system safety program. As well, for an SMS, the key to that is how does your SMS play into your assessment and protection of public.
We don't have any more questions right now, so we're kind of waiting. Please ask your questions. Again, we're opening it up now to anything you've heard all day. So Subpart A, Subpart B, 450-101, system safety program, or hazard control strategies. Again, we'll all visually think of the guy running around with the microphone. All right, I think there may be a question coming in. So I see the question here. I think there might actually be a typo in it, but I see what I think the question is what is the difference between a functional hazard analysis and a functional hazard list? Although the question says functional hazard analysis twice. It's different. It's difficult to understand the intent of 450-107C without knowing the difference.
Okay, well, there's such a thing as a preliminary hazard list, and that is kind of a brainstorming exercise that's performed generally in the very early stages of a system safety, specifically system safety effort. So in that, the functional hazard analysis comes after that, and what it does is as soon as the system starts to come together, you perform a functional hazard analysis where you decompose the entire system and are able to then assess specific functional failures of that system and determine what the end effect of those failures on the full up system will be. So a preliminary hazard list, if that's what was being alluded to, doesn't necessarily accomplish that. It's almost like a brainstorming session to determine what are just random hazards that generally can be expected from these types of operations. Whereas the functional hazard analysis breaks down the entire system, assesses all the functional failures over the phases of the flight, and allows you to clearly identify what the hazards to the public are based on the functions of the system.
So I think that's a really great.
Hey, Christopher, I think also part of the question is.
Yeah, the actual
I
question.
think also part of that question is.
Oh, sorry. Yeah, so I actually did read it incorrectly.
How does a functional hazard analysis compare to
a flight hazard?
Flight hazard analysis?
How's a functional hazard analysis?
The two FHA, the functional hazard analysis and the flight hazard analysis, how are they different?
Yeah.
Okay.
And they're so close, I couldn't even see them on the screen different.
Yeah. So the functional hazard analysis. So first off, in 450, the functional hazard analysis is always required. The flight hazard analysis is a hazard control strategy that may be determined, may be chosen, but may be determined based on whether, as you do your assessment of your functional failures and your hazards that come from that, you can determine what hazard control strategy best suits the operator. The flight hazard, so the functional hazard analysis, once you've determined what that hazard control strategy is, to complete that system safety product, you would validate what those hazard control strategies are, that they actually reduce the risk of those hazards to the public. If you determine to do a flight hazard analysis, or if you're driven to do a flight hazard analysis by the fact that you can't adequately mitigate those risks, those hazards to the public based on use of flight abort, physical containment, or wind weighting, then you have to go and do a more in-depth system safety assessment, which is the flight hazard analysis that looks at the causes of those functional failures and identifies mitigation specific to those causes, relates those resulting risk assessment of those subsystem failures to the hazards to give you a system mission level hazard assessment. And at that point, if you do not meet the requirement in 450-109 of acceptable level, then you would have to mitigate at the system mission level utilizing either a specific flight safety system or operational requirements to meet the acceptable level identified in 450-109, I believe B3.
That's great, thanks. So there was a question about the ground safety policy and where to find that. So if you go to faa.gov/space, there's a bar on the left side that says legislation, policies, regulation, and guidance. And once you click there, you go all the way to the bottom, and there's actually a table, and it's the first document on that table. And it's called Statement of Policy on Waiving Ground Safety Regulations at Cape Canaveral Air Force Station, Vandenberg Air Force Base, Wallops Flight Facility, and Kennedy Space Center. And again, that's not necessarily tied to Part 450. The effort, was a complementary effort. Under 450, we have a slightly different way that we're going to be handling ground safety, and we're going to cover that in the ground safety section. Next up, will AST require implementation of a standardized? Oh, wait. No, my question went away.
One, go back to the question before. We will cover flight hazard analysis tomorrow morning.
That's a good point. Okay, I'm waiting for some more questions. Okay, so just to be clear, did Randy include Vandenberg and Wallops as ranges with acceptable ground safety standards? Because preamble page 116 only mentions Kennedy and Cape Canaveral, and that is for the 450-179 Bravo. And again, we're going to cover the 450-179 Bravo section in the ground safety section. But Randy, if you wanted to speak to why the preamble only mentions for 450 Cape Canaveral and Kennedy. Or I can.
I think I actually looked that up. I believe those other two would certainly apply. I don't know why they wouldn't. I don't know actually why we didn't bring the other two in the preamble.
Yeah, I think the intent is as posted in the ground safety policy.
Yes.
And what we did say in the preamble for this particular section under ground safety is that we would be working MOAs or posting on our website which of the 450, 179 Bravo sections under ground safety would be applicable. It's, you know, we don't have any other questions queued up, so I don't mind speaking to it a little bit, but instead of a waiver, it would be a different process, and that is an operator would have to have an agreement that they're launching from that site, and they would have to obviously be launching from the site. And then the third item would be that it wouldn't be inconsistent with our statutory oversight, which is a little bit different standard. So we're going to be posting those sites that have met that bar onto our website, and those are in work. Any other queued questions? Okay. Regarding the Federal Range reciprocity, there's no mention of Edwards Air Force Base or China Lake. Are they missing on purpose? So I think that as sites come up, we will be evaluating them. And at this point, we've only evaluated those 4. And, you know, one of the things that is really important to note, we still always have under services and agreements that we would have an LSSA-like process for any particular federal entity, that if they met the requirements of the part, we can accept their services. And we have another question about the Reagan test site. Similarly, again, I think that is something that as additional sites come up and there's additional questions about those, we would be working with operators and our government partners. Okay, well, I'll just be patient while we're watching the questions kind of coming in. Waiting for our next one. So we'll talk a little bit more one-on-one with applicants about their particular sites for ground safety. So any questions from any of the other areas we talked about with, just as a refresh, we covered a lot of different topics with the scope of vehicle license, issuance, duration, pre-application consultation, incremental review, means of compliance, equivalent levels of safety, the use of safety element approvals, policy payload, and some others. Safety criteria, including neighboring operations personnel, critical assets. We've covered a lot of ground today. If there's questions in any of those areas, please feel free. Now's the time. There was a request if we could go back to one of the charts, and I don't see any harm in doing that. Let me just find out. Let me look through my charts to find the one that they're looking for.
Yeah, the life cycle
believe-
slide.
Yeah, I think it's chart, Tara, it's on page 12, chart 12. And this graphic is actually also on the FAA, .gov/space. Clicking on the 450 page, this graphic is actually right on that main Part 450 page. And again, just to review what this has our review process. It's a little bit different view of it than Ken Wong showed. We typically had a graphic where we showed just some boxes, and you have pre-application on one side that results in an application. It goes into a big box that has the 5 reviews that we do. And then on the, after the evaluation, out pops the license. And the reason for this graphic is to kind of show that there's a cycle to it where it kind of begins again, and it's more of managing a long-term license. We think Part 450 is going to have some very long life licenses with these vehicle programs. That they will continue to modify their licenses as they modify their vehicles and their operation, and also as they add additional vehicles or add additional launch sites. So the management of a license is actually really important under Part 450. Was there any particular questions on the life cycle management? And I think, one thing I'll mention here, Ken did a great job walking through some of the pre-application compliance planning templates and Annette as well. And, these are optional, but the applicant must demonstrate compliance to the FAA. What we're giving you is a sample template to do that efficiently. If you use these, it'll go right into our processes and make the process more efficient. I think there was a request for another chart. Let's see if we can get rid of that one. The other thing is, you all can, these charts are on the website, faa.gov/space. Click on the Part 450 website, and all of the day 1 charts are up on the website.
And day 2 and day 3.
And day 2 and day 3. So chart 143 was requested, the generic life cycle for a launch and reentry system. Chris, I think that was your chart.
Yes.
Okay, we've got potentially another question coming in. And I know this takes a little longer than it would in person, so please bear with us. So I think this chart actually is a great representation of not only the life cycle of the licensing, but also of the life cycle of the system, and how system safety program really covers the life cycle of the program as well. All right, well, it is 4 o'clock Eastern. We had another half an hour approximately for Q&A, but if there's no more questions, we'll just give it another couple minutes. Again, open to any topic under 450-101 or Subpart A or B. The other thing is all the questions, some of the questions that you guys may be putting in, and we also receive some questions in writing before the workshop. We're trying to filter as many of those through. Some we need a little bit more time to think about, so we will be responding in writing. And actually, we'll respond to in writing to all of them. The Zoom webinar will give us a report, and we will get all of the questions, and we will be posting those to our website at some point after the workshop, so that everybody gets to see all the questions. So tomorrow morning, while we're waiting for additional questions, we are going to be kicking off the day with flight abort, our primary hazard control strategies that is typical for expendable launch vehicles. And then we'll move into flight hazard analysis. So hopefully that will help illustrate that question we had about the difference between flight hazard analysis and functional hazard analysis. And then we will cover the remainder of the other two hazard control strategies. And then we're going to dive in after lunch to flight safety analysis. So with that, I think that we will adjourn. Feel free to, if you have additional questions, to capture those, and then we can possibly answer those more tomorrow. With that, I think I'll close out the session, and we'll hope to see everybody back here tomorrow.